여러분 안녕하십니까?
Good morning, ladies and gentlemen. Welcome to day 2 of the Korea Space Forum. Thank you for joining us once again. My name is Yu Una, and I'm your English MC for today as well as yesterday. Korea's challenge to realize the space economy, Korea Space Forum Day 2, will be conducted under the theme of corporate challenges in responding to the global space economy.
전반에 대한
We discussed the overall policy vision, which is the future space economy roadmap, yesterday. We also invited experts in the area of space development from Luxembourg, Latin America, Thailand, as well as America and Japan. On day 2 today, we will be talking about the challenges that corporations take on in the field of space economy. This event is brought to you, hosted by the Ministry of Science and ICT and Donga Science, and is organized by the Korea Association for Space Tech Promotion, Korea Aerospace Research Institute, Korea Astronomy and Space Science Institute, Space Policy Research Center, and Korea Testing Laboratory. You are able to participate online on spaceforum.kr or Kari TV and Donga Science News Space. If you have any questions to the presenters or the experts, you may raise your questions on the chatting, and we will take a look at it and ensure that we can get answers back to you. We ask for your active participation.
네, 이제 바로
Now we will start day 2 of the forum. Corporate challenges in responding to the global space economy will be kicked off by a keynote speech. I'd like to invite the managing partner, Chad Anderson of Space Capital, who will be talking about challenges of venture companies in space economy. Please welcome him with a big round of applause.
Last year, venture momentum kicked off and set all-time records for investment in the space economy. But the global financial markets have slowed the pace of deployment into the category. The funding environment is getting tighter, particularly for companies building space infrastructure. At the same time, the space economy continues to grow rapidly, and innovation is happening at an unprecedented pace. Supply chains are strained, and the talent pool is struggling to keep up with demand. Structural changes to the ecosystem, like Starship, will create an incredible amount of opportunity, but will also cause some short-term pain for founders and investors who aren't prepared for the magnitude of the change that's coming. Today, we'll discuss the challenges and opportunities of startups in the space economy. We'll examine how global economic headwinds are impacting the category, which industries are most affected, and which are best positioned to weather the storm. My name is Chad Anderson, and I'm a founder and managing partner at Space Capital, a New York-based venture capital firm investing in the space economy, specifically focused on unlocking the value in space technology stacks such as GPS, geospatial intelligence, and satellite communications. We're actively investing out of our third fund with over 100 million under management. We are backed by a great group of LPs, including Kenkoa Aerospace, who I believe is in the audience here today. Our partners have built rockets, satellites, and operating systems. We have founded companies with assets that are currently in space and have led multiple exits as operators. We've been pioneering investment in this category for 10 years, and now we have literally written the book on the subject with the space economy, which will be published by Wiley and available in this coming spring. And market education is an integral part of our strategy at Space Capital, and this book joins a wide array of thesis papers, blog posts, podcast episodes, and television appearances, all of which are available for free on our website. And it doesn't look like my slides are changing. So I'm going to leave it in this mode and see if this works. So we have been operating in space for decades, but it has only recently become a category for investment, which means that most of the activity is in the private markets and is coming from venture capital funds, primarily private equity, corporates, and more recently, crossover investors. Last year, venture capital momentum set all-time records for investment in the space economy. But the global financial markets have slowed the pace of deployment. We began publishing the Space Investment Quarterly in 2017 with the aim of uncovering insights about investing in the space economy. And this free report tracks private market equity investment activity and startup trends into the category. We published our latest Q3 report last month, and by our accounting, there has now been $268 billion of equity investment into 1,700 unique space companies in the space economy over the past 10 years. Most of that capital has gone to the US and China, which together account for a full 77% of total investment over the last decade. While launch and emerging industries get most of the media coverage, they only account for 11% and 1% of total investment, respectively. Most of the capital into the space economy has gone to the satellites industry, and much of that into downstream satellite applications. But none of these industries were spared from the macro market pressures. In the US, expectations for Q3 were high that the Fed would tame inflation and investors would get back to investing capital. Economists were forecasting headline CPI to slow, but instead it rose with stubbornly high rents and food prices. The Fed responded in September with another rate increase, resulting in the fastest rate hike cycle since 1988. Which is putting pressure on equity and debt markets, both broadly ending down for the quarter. And these macroeconomic factors directly impact venture capital and private markets, making it harder for startups to raise money. At the same time, venture fundraising set a new annual record with $151 billion closed through September, and nearly $300 billion of dry powder on the sidelines. Many expected that VCs would get back to investing after the summer holiday, but PitchBook data shows fewer deals closing in Q3 when compared to last year and less total capital deployed. Also, that $300 billion is not just sitting in fund managers' bank accounts waiting to be deployed. In order to be invested, it needs to be called from their investors, which is creating a bit of a cash crunch. Capital calls currently outweigh distributions for private market funds, and investors are in an uncomfortable position where they need to offload their liquid assets to meet their illiquid obligations, which could mean even deeper losses for public equities. 2021 marked the end of a 20-year bull run in the US public markets and a similarly epic bull run across global markets. Last year, venture momentum set all-time records for investment in space infrastructure, but the funding environment is getting tighter, particularly in capital-intensive industries like launch and emerging industries. The risk-off environment has meant that VCs are refocusing on enterprise SaaS, and deep tech is feeling the pain as investments decrease across quantum, robotics, and space infrastructure. VC investment volume in space, particularly infrastructure, has fallen significantly more than the broader market. In fact, Q3 is one of the lowest quarters for private investment in the space economy over the last 5 years. Total investment year to date saw a steep decline versus Q3 last year. VC investment volume in space was down 44% year over year versus the broader market at 31%. As this category has grown, more people and more organizations are looking to get involved. And since the category is still nascent, many see an opportunity to establish themselves as experts in a hot new area. But unfortunately, in their efforts to win mind share, we're seeing many of them perpetuate misconceptions, provide uninformed opinions, and limited viewpoints that lack context. For example, in the launch of their coverage of this category, Credit Suisse said, quote, "The space industry is one that largely consists of capital-intensive companies operating in a competitive arena with challenged unit economics, high technical and operational risks, unsupportive base rates, and a resistance towards consolidation," end quote. Their analysts went on to highlight a few key risks that are specific to the space industry: tendency toward speculative bubbles driven by consistently overestimating potential revenue and underestimating costs, the best opportunities locked up by the primes and by SpaceX, unique exposure to tightening macro headwinds, and high cash burn rates and shortening runways. Nothing that they said is wrong per se, but they are looking at the opportunity through a very narrow lens. They're focused only on space infrastructure, for which all of these things are true. And it makes sense that they would focus their coverage on infrastructure, given that launch and emerging industries get most of the media coverage. But again, they only account for 1/10 of all investment activity. The vast majority of the capital into the space economy has gone to satellites industry, and much of that into satellite applications. The applications is where the real value accrues, and those data businesses are highly resilient to macro market pressures. The CEOs of 5 US launch companies that successfully reached orbit in the past 20 years will tell you that tapping into the global market, the global launch market, isn't enough. All 5 of them are moving down the value chain into everything from building spacecraft to satellite services and lunar landers. Starting with SpaceX and its satellite manufacturing and internet business, Musk has said that the company's launch business likely peaks out at about $3 billion a year. But Starlink is expected to tap into a market that would be more than 10 times that. Likewise, within GPS, it wasn't the satellite hardware that generated trillions of dollars in economic value and some of the largest venture outcomes in history. It was the applications, the location-based services that were built on top of those signals generated from orbit. The truth is that some bad deals got done in the market mania of the last couple of years, particularly last year. Certainly, we expect that some individual companies will fail, particularly SPACs and less understood companies operating in emerging industries. And based on some of the portfolios we've seen, we expect to see entire funds fail. And this can take a long time to play out in the private markets, where information can be limited and zombie companies can limp along for years. As a leading indicator, though, we're beginning to see a wave of write-downs across venture-backed growth companies, and space companies are not immune. Earlier this year, we broke out emerging industries in our data for the first time as a subset of infrastructure, and I think that this data really highlights the irrational exuberance of 2021. Our data shows that over $3 billion has been invested in these emerging industries over the past decade, with nearly half of that total invested last year alone. And this record level of investment was driven by venture capital firms, many of whom, in the height of market mania, were investing in the category for the first time. So when you hear investors say the space economy is in a bubble, or that it's about to fall off the edge of a cliff, you might want to look at their portfolio and see if they're merely describing their limited experience with this 1% of the highest risk business plans. It's not nearly enough to merely identify a market opportunity. You also need the category knowledge and the experience to pick the winners. But despite these headwinds, overall, we see the space economy is not at any existential risk. And that's because space technologies are critical infrastructure. They're providing essential data to enterprises and governments, empowering the world's largest industries. While we do believe the macro environment will disproportionately affect funding for capital-intensive companies for the foreseeable future, companies providing data, insights, and critical services to enterprises and governments will be better situated to grow revenues in the near term and therefore better positioned to raise additional funding. At the same time, the space economy continues to grow rapidly, and innovation is happening at an unprecedented pace, creating different challenges. Supply chains are strained, and the talent pool is struggling to keep up with demand. Last year saw the highest number of orbital launches in a calendar year. The previous record was set back in 1984. This year has already set a new record with 156 launches as of Friday, and I haven't checked where we are today, but I know that we had a couple of launches over the weekend. We're seeing the satellite population grow dramatically. Just a few years ago, there were 800 satellites in low Earth orbit. Now there's close to 4,000, and pretty soon we're going to be up in the tens of thousands. When Starship comes online, this is going to increase exponentially. This rapidly changing environment makes it even more vital that space operators ensure their valuable assets. But compared to other Earthbound industries, there's a significant lack of data available on hazards in space. This knowledge gap results in significant uncertainties in the underwriting analysis for space coverage. Understandably, insurers have been pulling out of the market for the past few years, but one of our portfolio companies is helping to fill that gap in data and is making the market addressable for insurance companies again. With a worldwide network of ground-based radars, Leo Labs provided a practical, cost-effective solution to orbital debris tracking, management, and mitigation. And they can do this at 10 times the precision and 1% the cost of traditional methods. In September, they launched their space insurance tool, which replaces the hours-long manual efforts required to integrate conclusions from various sources to assess collision risk. And with this insurance tool, all the necessary data and risk algorithms are embedded into one interactive dashboard, giving underwriters access to near real-time analysis. I'm not going to spend too much time on Starship because I imagine most people in this room are familiar with the next generation launch vehicle, but it's worth mentioning. Every year since 2013 has seen a record amount of investment into space infrastructure. But much of that capital was chasing solutions based on a 10-year-old Falcon 9 launch paradigm. With Starship, we're entering a new phase of infrastructure development. It will make much of our existing space infrastructure obsolete, and billions of dollars of wealth and capital investments will be transferred to new solutions. The Falcon 9, which entered commercial service in 2009 and pioneered reusability in 2015, brought the cost of orbit crashing down, ushering in a wave of entrepreneurship and innovation. It spurred competition, and during this period, many pioneering companies began taking advantage of low-cost access to orbit by launching satellite constellations of unprecedented quantity and capability. The next phase will begin in earnest with the arrival of Starship, a revolutionary new launch vehicle that promises to shake up all of the givens of space, namely that it's expensive and difficult to get to, and that every ounce matters. Just like SpaceX did with its Falcon rocket 10 years ago, Starship will fundamentally change how we operate in space. It will further remove barriers to entry and stimulate the development of new emerging industries. And as investors in this category, we're looking for founders who see what's coming and are building for this new reality. Now, talking directly to leaders in the space economy, you quickly discover that talent is the biggest obstacle to growth today. Attracting talent isn't as easy as it was early on. Today, there's more competition, increasing interest in things like self-driving cars, robotics, and climate tech. Also, many companies in the space economy have raised a lot of capital, which is inflating salaries quite a bit. A decade ago, companies like SpaceX had to lure software engineers away from Google and Facebook, and avionics engineers away from NASA and large defense contractors. Today, the talent war continues much closer to home as cutting-edge startups within the space economy battle each other for the world-class employees they need to execute their ambitious visions. The competition can be off the charts in case of specialized in-demand skills like radio frequency engineers, where the supply has yet to catch up with the sudden surge in demand. However, those talent gaps will close. A generation of academically gifted millennials and younger workers are turning to space in search of more meaningful work. In parallel, older scientific and engineering talent, frustrated with the bureaucracy at large incumbents, are making late-stage career shifts for more dynamic opportunities. This combination of demand for talent and pools of hidden talent led us to create a career platform called Space Talent as a marketplace to connect companies with space economy with the world's best employees. With 30,000 open roles in 700 companies, Space Talent matches credible employers with top talent, while providing insights into an ever-expanding range of opportunities. When most people think of space, they think rockets. Until now, that's been an area of great opportunity. There's probably been 100x growth in launch over the last 5 years. Demand for propulsion engineers, for example, has been fierce. In fact, all the high-level propulsion engineers have been building engines across the big producers for a decade or two. However, the areas of demand are changing as the space economy evolves. The single greatest position in demand across our ecosystem is the software engineer. Software optimizes hardware, so these engineers play a crucial role. They're building more efficient supply chains, they're creating more powerful business intelligence tools. And for example, many of the systems that SpaceX used at SpaceX internally are proprietary solutions developed by its software engineers. Another indication of the demand for talent in the space economy is the amount of poaching that occurs on a regular basis. Recruiters play hardball and churn is high. Churn is a pressing problem, particularly for infrastructure companies. Long-term projects end up being handed off again and again. On the bright side, demand spurs supply. The core skills of the space economy, from mechatronics to machine learning, are being learned by a larger and larger cohorts. In June of every year, an ever larger wave of graduates with the right stuff enters the workforce. These market headwinds are causing challenges, particularly for space infrastructure. But there are many more opportunities developing in the applications, the layer that leverages the data from these space-based assets. When most people think of space, the first thing that comes to mind is the Apollo moon landings, the International Space Station, and grand human achievement. Most people don't think of the entrepreneurs that are transforming nearly every major industry here on Earth. But that's the multi-trillion-dollar opportunity that everyone here at this event is involved in. The space economy is much more than just rockets and satellite hardware. In fact, space technologies are next-generation digital infrastructure. They're the invisible backbone that powers our global economy. GPS, geospatial intelligence, and satellite communications already play a critical role in the world's largest industries. And space technologies have already delivered massive returns for investors. GPS has generated trillions of dollars in economic value and some of the largest venture outcomes in history. And while we believe that the macro market environment will continue to cause headwinds for some space companies, particularly infrastructure, we don't believe that the space economy is at existential risk. In fact, we believe that the majority of space companies are counter-cyclical and resilient to macro market conditions. What often gets lost in the noise is that space technologies are playing an increasingly important role in the global economy. For example, with the iPhone 14 launch this quarter, Apple announced its partnership with Globalstar to provide emergency communication services to its 1 billion users. While this service will only offer text messaging to start, this initial step to integrate SATCOM into mobile devices has significant implications. Apple is no stranger to innovating with satellite capabilities. In the GPS playbook, we explore how Apple's integration of GPS into the iPhone 3G helped fuel the rise of location-based services and companies like Uber, Lyft, and Grubhub. Apple wasn't alone in their SATCOM announcement this quarter. T-Mobile and SpaceX also announced plans to bring persistent, ubiquitous coverage to U.S. customers using Starlink to provide satellite direct-to-mobile service. And in response, AT&T's CEO claimed to have an 18-month head start on both of them. But regardless of who comes out on top, this convergence of terrestrial and satellite communications networks provides tremendous opportunity to rethink how our data is captured, routed, stored, and utilized. The SATCOM playbook, which we published earlier this year, unpacks the innovations driving these changes and what it could mean for our day-to-day lives. For example, space technologies are enabling our energy transition. Areas lacking solid terrestrial connectivity often provide the greatest opportunity for companies looking to roll out new energy sources, such as solar or wind energy. Accessing satellite connectivity can allow for remote monitoring of deployments from anywhere on Earth, even offshore or off-grid, and in areas with no existing comms infrastructure. Focus on new sources won't be enough. Retrofitting legacy assets to improve their sustainability and efficiency, as well as decommissioning outdated ones, will also be required. To enable these projects, monitoring technologies such as predictive maintenance, tracking, and fault detection can be deployed on equipment, but only if the required connectivity is available. Gathering continuous remote operational insights is key wherever these projects take place. Even at a governance level, the increased focus on ESG reporting can benefit from digitization to enable remote gathering of accurate and timely data for presentation to shareholders, partners, and customers. And that insight comes from data which can be transmitted from anywhere, anytime, as a result of new space technology. Additionally, record revenues for remote sensing companies are demonstrating how the space economy is both countercyclical and resilient to macro market conditions. In September, Planet, now publicly traded on the New York Stock Exchange, announced a 59% increase in fiscal year Q2 revenue year over year, with net dollar retention of 125%. This strong performance was driven by growth in both enterprise and government customers whose operations rely on critical data and insights from satellites. In times of uncertainty, business leaders are hungry for insights and information, which is exactly the type of data that space companies provide. And in fact, many of our portfolio companies have seen an increase in demand for their products and services. Overall, this is resulting in an incredible amount of innovation, and we see massive opportunity ahead. The global geospatial market is expected to grow from 63 billion to 148 billion over the next 5 years. Satellites transformed modern mapping from static approximations into dynamic reflections of our world and the activity within it. In the early 2010s, the use of distributed networks of small satellites made it more cost-effective to capture timely geospatial data at global scale. Today, a variety of geospatial platforms, including satellites, capture data at different altitudes, benefiting from low-cost components and decades of GIS product development. The adoption of cloud, edge computing, AI ML capabilities, and increasingly powerful geospatial APIs and SDKs are making the benefits of geospatial intelligence more accessible. Developers no longer need to be experts in image capture, data processing, or object detection, and instead can focus on building specialized applications tailored to unique customers, similar to the proliferation of GPS brought about by Apple's App Store. We're now witnessing the birth of a new investment category in geospatial intelligence that could exceed the $36 billion location-based services market. Demand for geospatial data is being quantified through marketplaces and used to inform what sensors and platforms will be built in the future. New breakthroughs in deep learning could eliminate human intervention entirely, unlocking more predictive intelligence that appears self-aware. We're beginning to see a future where every government, industry, and customer can benefit from real-time intelligence about the world around them. A seemingly infinite number of venture-scale businesses are now being built in multi-trillion-dollar global industries like agriculture, insurance, and climate markets. The ability to collect, process, and analyze endless amounts of geospatial data is creating powerful new applications that are helping reshape how the largest global industries operate. And I will skip ahead a little bit since we lost a few minutes. All of this to summarize that despite the challenges caused by macro market headwinds, we have never been more bullish on space as an investment category, particularly where it comes to the applications.
Thank you very much, Managing Partner Chad Anderson. 여러분 감사합니다. 시간이 조금 타이트해서 바로 다음 세션으로 진행하도록 하겠습니다. 이제 세 번째 세션이 준비되어 있는데요. 우주 신산업 분야
Now we have the third session in store for you. So we are going to begin our third session. The first speaker will talk about, we are going to introduce Logan Weir from Blue Origin, and he will give us a speech on the prospect and status of new space industry, especially Blue Origin. Please welcome him with a big round of applause.
Good morning. I would like to get a quick communications and video check if that's possible.
Your audio and video is working just fine. The floor is yours. Thank you.
Thank you. Thank you for having me. And thank you to the Ministry of Science for hosting the event in Seoul. I very much wish that I was there in Seoul with you all, especially at the JW Marriott. I have become quite fond of visiting Seoul. I was just at the JW just less than a month ago, so I wish I was back, but I very much appreciate the opportunity to talk through what Blue Origin, a US-based company based in Seattle, is envisioning for the future of the space economy. And the way that we see it at Blue Origin, just quite frankly, is it's going to take thousands and thousands of organizations and millions of people in order to realize the potential of the space economy. And quite humbly, Blue Origin is just one of those companies. It's one of those organizations in the thousands of organizations that are required to realize the potential of what we see as being a very, very, very large space economy. And we're just on the front end of that vision. And I'm going to start by giving a brief presentation about why we're pursuing a space economy in the first place, what is driving us to realize the potential applications of a very, very unique environment in space. And then I'll talk a bit about how we're pursuing that kind of end vision. So Blue Origin is envisioning a future where millions of people are living and working in space. And why are we doing that? We're doing that in order to benefit Earth. So that's our vision, is the space economy for the benefit of Earth. Earth is the best planet in the solar system. We have sent probes to all of the other planets, and Earth is by far the best planet. And it's a quite fragile origin for humanity, and is finite. We're seeing that much of the activity, the heavy industrial activity that is done on Earth, and its destructive outcomes. And much of that activity, we envision, can be done outside of the Earth's atmosphere. It can be done in space. And our solar system alone has an incredible abundance of resources. Most locally, the moon has an incredible amount of water ice. Beyond that, there are meteorites, asteroids. There is an incredible amount of metals. There are an incredible amount of resources in the in-space environment that has the potential to bolster not only a space economy, but help us to protect our planet. So that's why we're doing this. And what we're doing, much of what Chad was kind of talking about early on in his presentation, is we're starting to build infrastructure on that road to space. And we're doing that in a few different ways. So the first step to beginning to realize the potential of the in-space economy is a radical reduction in the cost of access to space. So we're taking those first steps globally in building launch systems, and at Blue Origin, we're building reusable launch systems in order to drastically reduce the cost of launching payload into space. And in addition, I'll talk about some other programs that are intended to reduce the cost of applications in space beyond just delivering the payload. There is a lot to be done with regard to building facilities that can host in-space activities. The second of the three gates is utilizing the in-space resources. So I had stated that there is an incredible abundance of resources in space. we need to figure out how to utilize those resources. First of all, how to access them, how to mine and then convert those resources into useful outcomes for humanity and for Blue Origin. We see that as ultimately benefiting our origin, which is Earth. And then finally, and I will reiterate again, Chad very acutely noted in his previous presentation the importance of the next generation in realizing this vision. This is a multi-generational endeavor. Many generations will be required in order to essentially build not only the infrastructure, but the applications and fully realize the potential of the in-space economy, as well as help to protect our planet. So Blue Origin is taking steps for each of these gates, and I'll talk a bit about each and every one of the programs that we're pursuing within Blue Origin to, first of all, radically reduce the cost of access to space, start thinking about utilizing in-space resources, and then how do we inspire the next generation to work in this industry and inspire the next generation to work in space for the benefit of Earth. There are 4 primary programs at Blue Origin with regard to reducing the cost of access to space. I talked a bit about reusable launch systems. New Shepard and New Glenn are reusable launch systems that Blue Origin has developed and is developing, and I'll talk in more detail about each of those. The engines program supports both New Shepard, the suborbital rocket, as well as New Glenn, the very, very large orbital rocket, and it also supports some of our advanced development programs, which is our 4th program on the far right, which starts to think about how do we promote applications in low Earth orbit or commercial destinations in low Earth orbit, and how do we think about a permanent human presence on the moon, etc. That's all kind of encompassed in our advanced development program. So I will very briefly talk about each one of these. The first is New Shepard. We're quite proud of New Shepard. New Shepard was our first step on our journey at Blue Origin. It is a suborbital rocket. It goes just above the Kármán line in just 100 kilometers into the atmosphere, and then it comes back. So it's a fully reusable launch system. Both the propulsion module as well as the crew capsule is a fully reusable launch system. And this reusable launch system is operational today. It currently launches both payloads, and what we're really proud to say is that it's the first suborbital commercial astronaut launch system, reusable launch system of its kind. And since around mid last year, when we flew our founder to space and brought him back, we have successfully since then flown 31 astronauts to space, which is quite a huge advancement in the amount of astronauts that have been to space. There's been only some odd 600 or so astronauts that have ever seen Earth from space or been to space. And these 31 astronauts, from a percentage perspective, represent approximately 5% of astronauts that have ever been to space. And what we're really excited to say is that it also represents over 9% of all women astronauts that have been to space. So we're starting to see a kind of incremental shift in representation of who can go. There's been a lot of firsts. The youngest astronaut that has ever been to space has flown to space on New Shepard. The first Portuguese astronaut, as well as the first Egyptian astronaut, flew to space on our most recent mission on New Shepard. So it's starting to realize a shift in how we access space and opening up access to space globally to everyone. Which is our first step, like I said, on our mission to kind of achieve the vision of millions of people living and working in space for the benefit of Earth. So just a couple snapshots of New Shepard. This is essentially the view of space after launch. The booster then comes back and lands on a landing pad, as well as the capsule comes back with both payloads and astronauts as well. Again, that was our first step. We have a motto at Blue Origin, which is Gratatum Ferociter. It is Latin for the phrase step by step ferociously. We are taking much of the learning from the reusable launch system that we built suborbitally, and we're taking some of that learning to build a very, very large orbital rocket, and that is New Glenn. And New Glenn, for scale's sake, is an order of magnitude different than New Shepard as a suborbital rocket. So for scale, the payload fairing, which is a 7-meter payload fairing on New Glenn, could fit the entire New Shepard suborbital rocket inside of it. This is a very, very large rocket. It is a 2-stage with a reusable first stage, an expendable second stage, and again, a very, very, very large payload volume for transporting payload to orbital space. This is an amazing system we're quite proud of. And in addition to that, that very large orbital system is bolstered by our rocket engines that we develop in-house at Blue Origin. We have a handful of engine developments. There is the BE-3 system, which supported the suborbital rocket New Shepard. There is the BE-3U variant. Again, this is just kind of a step-by-step incremental approach at Blue Origin. BE-3U is the second stage of New Glenn. BE-4 is a very, very, very large 550,000-pound thrust class engine. You can see it there, test firing in West Texas at our test stand. There are many of these engines on the New Glenn rocket. This is something that we're also very proud to say. We have built the first 2 BE-4 flight engines and delivered those to our first commercial engines customer, which is United Launch Alliance, for their Vulcan rocket. So this is a very critical achievement for Blue Origin in the last quarter, having delivered the first 2 flight engines to our commercial customer, ULA. And then on the far right is the BE-7 engine supporting our advanced development programs. And I pulled this picture just because it's quite awe-inspiring of just the kind of sheer power in West Texas where this BE-4 engine is tested. And I'll kind of round this this conversation around the building infrastructure for realizing the potential of a space economy with advanced development programs. It's taking a lot of the how do we get access to space, and then once we have access to space in a reusable, repeatable, and sustainable way, how do we utilize the in-space environment? In the picture here with on this slide is of Orbital Reef. Orbital Reef we announced just over a year ago at IAC in Dubai is very much like the coral reef that is kind of the backbone of our ocean infrastructure. There is the intent here with Orbital Reef for it to be the backbone of the LEO commercial space economy. So this is an expandable, it's a scalable system where we are building the core infrastructure, the core power, the core communications capability, the core structural capability, and then allowing other organizations. Like I said, there need to be thousands and thousands of organizations in order to realize the potential of the space economy. Those organizations bringing their business or bringing their use case or bringing their science or bringing their experiences to low Earth orbit. This is Orbital Reef. We're very, very excited about this project. And what's most exciting to me in my role as a commercial director and in leading business development internationally for Blue Origin is that this is a project that will only be successful with international participation. So we are inspired that organizations, both commercial organizations as well as institutions around the world, will develop applications, will develop businesses, and will bring those businesses and applications to space and into Orbital Reef. The other critical note that I have on advanced development programs at Blue Origin is Blue Origin, since its inception, has been committed to getting humans back to the moon. And we are committed to doing that in a sustainable and permanent way. This is a very exciting endeavor for Blue Origin, as what we see the moon represents is, like I said in the beginning, a very, very vast amount of in-space resources, a very, very large amount of oxygen is available, and hydrogen is available on the moon. The moon is absolutely somewhere that humans need to be in a permanent and sustainable way. So we are committed to this. We see that this is an incredibly critical endeavor for humanity in order to take that next step to utilizing in-space resources for the benefit of Earth. And to round out the presentation overall, I must note the importance again of inspiring the next generation, as this is a multi-generational endeavor to realize the space economy and do that for the benefit of Earth. Club for the Future is Blue Origin's non-for-profit, where we have projects, curriculum, inspiring the next generation to work in STEM or STEAM around the world. one of the very kind of fun and interesting projects that we have for Club for the Future is we take postcards and we have anyone of all ages fill out their vision of the future, fill out their vision of space on the postcard. We then send those postcards to space, and we have sent those to space on New Shepard, our suborbital rocket. We stamp those postcards having went to space, and we mail them back in the post. So this is something that we see as inspiring the next generation by having an actual physical artifact that has been flown to space. And we've seen that it's incredibly inspiring. This is just one of the initiatives that we're undertaking at Club for the Future globally to inspire the next generation. And there are others, and we hope to get, again, international participation, including that of Korea institutionally. That would be absolutely something that we would be very, very, very excited about and would work toward. So again, that is the Blue Origin vision of the space economy, and to say it one more time, it is all in an effort for the benefit of Earth. Earth is our origin, and the future of humanity requires it. So thank you for the time, and I'd open it up to any questions if there is time available.
Thank you very much, Director Logan Ware. 네.
It seems Blue Origin is really going into space exploration for the future of Earth. I'd like to invite the second presenter. It is Kim Yong-il of JustTech, who will be talking about the development challenges and achievements of key satellite components. Let's welcome him to the stage with a big round of applause. Hello. Today I will be talking about not a big theme, but it may be boring and it could be very expensive. But I would say these are parts that need to be developed as a fundamental for any space endeavor. I'm going to talk about three companies that are integrated, Hostech and JustTech. CosmoWorks operates satellites, and we have application businesses in the works. In April of 2023, May, as well as at the end of 2023 through 2024, we are going to launch 3U, which is a cube satellite. And we are thinking of a 100-kilogram mini satellite. We are going to launch the first one in July of 2025, the second in November. And once we test that, if there are no other issues, we are going to launch more in 2026 to create a constellation satellites. Hostech is a company that takes care of optical components, and attitude determination is done by JustTech. We call this the reaction hill. There are several models in the portfolio. control moment gyro and control moment gyros are some of the products that we are also working on. In CosmoWorks, we use satellites to test and validate the parts that will be sent to space. I'll give you a bit of introduction of OSTEC. We started in 2018 and as a UAT. The golden disc that you see in the middle are used in surveillance aircrafts as well. We have three main businesses. Air bearing is used in semiconductors. We have optical components. We don't do small optical components, but those with a radius of 100 millimeters. And then the last is UAV. We use computers to drive unmanned vehicles up to 300 kilometers. We are doing a diverse portfolio in our optical components, from silicon covers all the way to glass parts. The most important here is that we can do lambda over 40. And we are developing opticals that can go on cube satellites so that we can launch in April and May of next year. We think the GSD will be 3.75. And you can think of that as performance good enough for a 100 kilogram satellite. And we want to do imaging with one photo. And we believe that we can take up 16 kilometers in the range. This is the telescope that we are developing, and these are the testing facilities. And this is a test photo. Even though there is shaking, you can see the apartments. Anything more precise than this could have legal complications, so I offer this to you. JustTech has been around for about 20 years. The objects that we currently produce are in semiconductors and precise machinery. We started with the linear motor, and it is still in our portfolio. This is the reaction hill array. We have JRW010, which has been in orbit for 4 years in space. Also, the launch, that is the cube satellites that are to be launched in early next year, are using these parts. And our part here has been used in Nuri AP satellite. And we have validated that there are no issues with it. And we are thinking of 4 to 5 years as its lifespan. We used various sciences. The reaction hill that is 5 MnM has been validated, and the 10 will be validated in May of next year. And we are currently receiving data from it in orbit. This can control 500 kilogram satellite or a 100 kilogram satellite. And we have put this on Nuri and are validating it. It is working very well, and the validation period is a minimum of 1 year, so please think of it as still in the validation process. We have facilities. These are the Cube satellite models that will be launched next year. The shape of the satellite is 3U. Korean 3U and 6U satellites have been launched. The difference is that CosmoWorks, JUSTEC, and OSTEC supplies them. You may think this is pretty normal, but satellite parts take 6 months to 1 year to create. But we can supply them within 2 to 3 months. So we are able to be flexible on the supply schedule. And while all countries are competing in the space field, I believe we can contribute to Korea's development. The difficulties we faced in the linear line in our display products is the domestic. When the line is operated 24 hours a day and we stop manufacturing on the line, that creates a lot of issues. However, once we created the trust, we have confidence as well, but I think our consumers also trust our products very much. And we are manufacturing products that can go into space. So I think you can trust the products that have been validated for 1 year. This is the electrical grid and the ADCS layout. Sun sensors or other cheap products are things that we buy, but the rest of the model is created by us. When we first started out, we did not find the products that we wanted, so we ended up developing our own. And this is another component that we are developing. The waves are used in satellite communication. And we anticipated this and registered for it. The UHS or S-band have too much, and X or CAR or Ku-band are possible. And we thought of what is the next generation technology. S-band has only 1 megabyte BPS worth of radio waves, which is very small. So as satellites become more advanced, communication needs increase. So I think if we use optical lasers, this can solve the issue. So that is an area that we are looking into. We also have experience with location systems and developing them. And we want to talk about the electricity system. And when we did this, we were able to control tracking performance within 3 arcsec without auto-guiding. So we wanted to use this system, and we created 2 types of telescopes. One is alt-azimuth type, and one is equatorial type. These are the biggest telescopes that are in operation in Korea. I believe there used to be one, but now it is not very smoothly operated. So JUSTEC is supplying telescopes that are operated 24/7. If you see on the top left corner, there is a shape of a Milky Way. This photo won #1 award in a photo contest, and we were able to validate the performance of our telescopes. So that was my presentation. If there are any questions, I think I can take about 2 questions. Could you raise your hand again if you have a question? I will give you the microphone. I think at the very back. If you don't have any questions, I have prepared the CMZ development process. And usually I get about a question or 2, so I took that out. But since we don't have any, I will continue with that. Trust is very important. We have to see it with your eyes first, and then we have to check whether it works. And then the heat, vacuum chamber, shock, EMI, and radioactive waves. Those are the 5 components that we test. We give vibrations because if it is launched, we have to check how much it will be impacted. We developed this test procedure within our company and are conducting the tests as such. Sometimes we joke that, are we selling a product or are we creating pieces of paper? We have volumes of books on testing procedures. So the thermal vacuum test can go through 12 cycles in a -30 to 60 Celsius. And we are testing the vacuum capacity as well. We thought this would be relatively easy because we were able to do -7 torr in semiconductor. We thought the space would be vacuum, but in low Earth orbit, in fact, it is not 100% zero gravity. And then there's the shock test. When the main satellite is launched, there is a lot of shock. So we want to test whether it can withstand the shock. So it can withstand 12 G, but ours is 20 G. The vibration test is for very short waves. very fast waves, and that can shake even a building. And this is the vibration test. Then there is the EMI test. And we have radioactive wave tests as well. Especially in space, we do not have products around stopped in orbit satellites. We focus on LEO satellites. Thankfully, there are testing facilities in Korea, so we are going over there to test our products. We have high and low radioactive wave testing. Also, lifespan test is another concern of our clients. They want to know how long our products can last. And we said 300 months with just a lubricant of 500 milligrams. That was the end of my presentation. Based on our experience, component development should only be done by yourself if you really need it. Please do use products that are already in the market as someone who has developed these products. We have done 7 to 10 years in this business. I have to tell you that the ROI is not great, but it is something that an engineer might want to do. Thank you very much.
김영일 대표님 정말 말씀 감사.
Thank you very much for your remarks. As a non-major layperson, all of the things on screen were quite difficult for me to understand, but I know that all of you are experts here, so it would have helped you a lot. Now we have the last presentation for this session. We have Antonio Vasquez Sarquia, the Head of Business Development of Allen Space. He will join us online. He will give us a presentation on the topic of SETMAR digitalization of maritime communication. Please greet him with a big round of applause.
To my team AEL. Good morning, everyone. Thank you for inviting me and invite our company. And I'm going to present a little bit at the beginning the company and what we do. And then I'm going to present one of our projects that we are carrying out right now. So we are at Allen Space. We are developers of small satellites or nano satellites. We design, integrate, manufacture, and operate nano satellites for our clients. So we are an integrator and manufacturer of small satellites and technology related to that. So we provide satellites for almost every need that is on the market, from fleet management to remote monitoring, air tracking, communications, airplane tracking, ship tracking, and so on. Our services go from taking away all the hassle that you can have. So frequency management, system engineering, payload integration, environmental test, launch management, ground station management. We start with design with the inputs of our clients, and we end with the operations for our customers. We do the integration, load management, and we integrate everything with our product, hardware, and software. In this slide, you can see a little bit of some of our products, our main products. We are mainly focused also on communications sides of the business. So we have ready-to-launch payloads for ADS-B, airplane tracking, AIS, boats tracking, spectrum monitoring, Earth observation, IoT, and we also provide software-defined radios and front ends for different bands for our clients. We also have platforms up to 16U and systems for onboard computer, onboard software, TTNC, high data rate transmitters, ground stations, and we also provide training packets as hands-on training. So the engineers from the customer can join us on the development of the satellites and learn how to perform designs or integrations or operations of the satellites that we build for them. So now that we have a brief overview of our services and what we do in our company, I'm going to present a project called SATMAR. SATMAR is a project that works for the digitalization of the maritime communications. SATMAR is a project that consists on the development and demonstration in orbit of the UVDS payload for demonstrate the UVD SAT payload for the technology. So the SATMAR project is backed by the Spanish government through the ports 4.0 of the ports of Spain. And the project will implement the VDS standard in order to help to become the key maritime radio communication system. It allows to provide bidirectional communications on the VHF marine frequency bands. This project is a consortium, and it's a consortium of Alen Space as the prime, and Egatel, other Spanish company that will develop the user terminals of the system. So we are developing the space payload as well as the satellite and providing the space service. And Egatel is going to develop the user terminals that are going to be on the boats, on the buoys, on the ground, let's say. But what is VDS? VDS is the VHF data exchange system. Is a new standard that integrates previous technology, previous standards like AIS. It's a radio communication system that provides a two-way communication and has is being designed to have communications between ships, ground stations, and satellites, everything together in the same ecosystem. To say in one way is the Internet of Things of the maritime industry. The VDSat is the satellite component of the VDS system. So it's thought to be a technology that allows to improve the communications and the tracking of the boats there where the terrestrial infrastructure is not, so they don't have enough coverage, and where nowadays the satellite, let's say the satellite coverage also it doesn't work really well. So in words of the YALA is an organization that integrates maritime industry as well as it's a non-profit organization. And in words of them about the VDSat benefits, mainly is a component that provides a very large area coverage, cost effective. So this is important because nowadays to provide services for the polar regions or some places where the coverage is overcrowded or they don't have enough terrestrial sensors, the maritime industry is a little bit deaf, let's say. So some use cases that are identified nowadays of this new standard goes from the tracking for manned and unmanned vehicles, as well as infrastructure monitoring for like buoys or platforms, also allows to improve the estimated time of arrival for the supply chain. Also allows to have in the same environment notice to provide weather information. Also, there are several use cases, you can see here some of them, that are identified right now to be useful in the near future. So we have to have in mind that this standard is really new. It has been, let's say, it has been specified really recently. So the applications and the uses that are going to span like a new market are huge. So here you have a nice overview of the full system. You can see it has several components. The traditional AIS is incorporated inside the VDS, as well as the ASM systems. So you can see that the communication between ships, between shores and ships, and ground and ships and satellites, everything is integrated into the same system. So you have all the communications under the same umbrella and under the same standard. So you don't have to depend on third-party providers for allow you to implement some of the services or the use cases that are nowadays identified. Sorry, I think I lost a little bit the connection. Okay, so the SATMAR is the first step of the SATMAR project is a 6U satellite that is going to be launched on 2024. The project started this year, 2022. So the SATMAR project, the first step is to launch this first satellite in order to demonstrate this technology and do demonstrations together with the ports of Spain or any other entity or company that is willing to test some of this technology by their own. So we are open to looking for partners for demonstrations or even for commercialization on the VDS market. So during this year, we made the kickoff, and the next year we are going to do the manufacturing integration of the satellite and third-party payloads. So in 2024, in Q1 of 2024, is expected to be launched, and the operations are thought to be operated until the end of 2025, and so on. So we have an in-orbit demonstration opportunity, as I mentioned before. So we offer a space on our satellite for companies or entities that wants to fly some of their payloads or some of their systems or a new application that they have in mind, but they don't want to they want to get rid away to all the hassle that can be made to own a satellite. So you just have the payloads on board of this satellite. As well as in our mind is to have open satellite in terms of the VDS data will be shared with other payloads in the satellite if it's interesting for them. That will be the case, for example, if you are thinking on payloads for spectrum monitoring or of these kind of systems. And this is a way to reduce costs and time for the owner of the payload. As I mentioned before, we also are looking for partners in the maritime industry for demonstrations or ways to commercialize the service that maybe you have some ideas that could help us to improve the system. So this satellite is the demonstrator of the mission. We know that we will have if we demonstrate successfully the technology and the VDS market, we know the government of Spain will be very interested to expand this technology into a constellation. So the main mission of the SATMAR project as a constellation is going to have VDS transceiver payloads, AIS receiver payloads, of course, is thought to be a third-party payloads through IOD. So you will have several of satellites with several of clients that will be able to operate their payloads and get the data, and also for spectrum monitoring that we believe that nowadays is and every day is one of key components of all this data. So at the end, to see how could end this technology is a system that allows communication between shore satellite ship. So a shore station could send a message to the data center to send information about maintenance or information about the level of some of the telemetry of the system. Could be remote platforms, could be voice, could be several applications, or also ship satellite shore. So both that send information to buoys that are on the ocean, or also for send information about the position through AIS or other services like ASM. So just to summarize the presentation, BDS will enable a robust two-way VHF digital communications to be provided with vessels, voice, and other equipment. New applications will be created that allows a new market and a new players to provide high added value services for the market. VDS will allow to implement also these new applications, but will allow us to implement it in an open way, since it's a worldwide standard. So you will be able to provide these services for all the world from one point. The VDS has something different with previous standard on the maritime industry, is that this incorporates the satellite component from the beginning, from the system definition. So this will improve the performance of the system. For last but not least, we are open here to offer space on our satellite, as well as we are looking for partners for the demonstrations on the VDS technology. This is everything. I left some minutes for Q&A. Here you have my contact data, so please send me an email, call me, WhatsApp, wherever. I will be open to discuss with you really happily.
Thank you very much, Mr. Garcia. 큰 박수 보내주십시오.
Please give him a big round of applause. I think satellite communication can be used in many different industries. And now that this is a mobile satellite communicator, I think that was very interesting. Thank you, everyone, for concentrating for such a long time. We will have a break, and we will have the next presentation at 10:50. We will see you in 20 minutes.
네, 이번 순서는요.
5G NTN and mega constellations, new opportunities for SATCOM antenna is the title of this session. I'd like to invite the EVP of Intel and Technologies, Lee Ho-jin. Please welcome him to the stage with a big round of applause. Once again, ladies and gentlemen, If you have any questions for the presenters here, please do let us know so we can give you the microphone. Thank you. Thank you. Good morning, ladies and gentlemen. I'm Lee Ho-jin. Today I will be talking about 5G NTN. SATCOM experts will know what it means. It's non-threshold satellites, and mega constellation is the new business opportunity for Intellian. Intellian is a satellite company. We are an SME, but our business is global. Our market share in maritime VSAT antenna sales is #1. I'm very proud of this statistic. And our annual revenue is $119 million. We have 600 global partners and customers all around the world, and we have 12 new firstly developed products. Let me just take off my mask. We have branches in 3 countries and logistics centers in 4 places. We have 6 in-house support centers. We are able to see real-time some of the feedback from our customers. Intellian Technologies was founded in 2004, and we started receiving OEMs from then on. And we started creating manufacturing products, and then we went public in 2016. And we have created branches in Shanghai, one by one. And we're going to be talking about this later, but we were able to receive awards for the V240MT. And we said that we would start partnering with satellite technology in 2018. And we have made an agreement to supply SES. I will get more into details later, but you can see our clients at the bottom of the page. We have marine satellite TVs, as you can see. We are currently manufacturing these products from HD to UHD now. There are several series. Inmarsat airband communication is another product that we have developed. For Inmarsat I4, we use networks all around the world. And we are developing this for broadbands. These do not work in Arctic regions because it is a location-based data. In the case of Certus C700, this is an antenna that can be for commercial vessels. And the data array can be possible up to 350K. And we are certified to use this in Japan as well. And as verified, when the ship vessel was crossing the Atlantic for a month, our products were very performing well during that time.
는 주파수 용량보다 훨씬
We call this the high throughput satellite, which has a better frequency. And we need devices that is fit for this satellite, which our company has produced. This is fit for K models. Since this is for KA bands, because of the characteristics where they have to be always on, we have taken that into account. And this supports the Inmarsat GX. The Inmarsat GX sold very well, so as I said before, our market share has become #1. And it's not here, but America's VRSat satellite is one of the things we are partnering for, and that was reported in the news. Now, I'd like to talk about the market share. We have a 58.9% market share. This market will continue to grow, and it will be twice as big in 2027. So I can say that the future is bright. Now let's talk about MEOs. Since we track on the oceans, when the satellite moves, so in the MEO, we can track it. For OB3 mPower, we are able to use our devices to track. But when we are tracking, our devices need to track. So we are providing the service. We have provided services for satellites on the oceans, but this is also something that can be used on land. So communication companies that are in remote areas can also use this broadband. So not only governments, but mining companies can use our services. We are developing models that can be switched between KU and KA. And this is the mega constellation that I mentioned earlier. They can operate on KU and KA. I believe that devices that can switch between KA and KU need to be available. And these models need to be able to communicate. So we created this multi-orbit, multi-band VSAT. As we develop from maritime to land, these devices are much needed. We need to create a gateway. The user interface is not enough. And as mega constellations continue to increase, the gateway antenna demand is increasing. And we are developing gateways for 2 to 3 meter MEOs. Since gateways are networks, the locations might be randomly spaced apart, so we use cloud technology.
이 중에서 특히 저희가 이제 가장 자랑하는 것은 LEO MU를 다 커버할 수 있는
We want to emphasize that we can cover LEO, MEO, and can cover 3 bands.
크기가 2.4m인데요. 주로 이제 크루즈
The size is 2.4 meters. When you go on a cruise, it goes around the world. And depending on the region, they might not use the band that your device has. Therefore, it is important for us to utilize different diverse bands as much as possible. We call this hybrid networking. If you look on the bottom right-hand corner, this is a cruise that is using installing the devices. You can integrate the GEO and MEO and use them together.
저희가 이제 이러한 KUKA 그리고 문법이기 때문에 이걸 이제 국에서 역시 사용할 수 있습니다.
Since this device can be used on KU and KA, military can use our products as well.
그리고 실제로 안테나도
And this could be critical for survival.
인터넷 만들어가지고 리스크를 해소할 수 있도록 해서 이렇게 플라이웨이나 또는 이제 KUK를 자동적으로 설치할 수 있는 그런 방법을
We offer devices that have flyaway function or can switch between KA, KU. This dual KA module has been certified for usage by America's double KA.
실제로 이제 밑에 아래는 이제 저희가 당장은 아니지만 저희가 이제 그런 게이트웨이 단말 그다음에 KUKA 이런
And it's not currently, but since our devices can switch between the different bands, it can be used in image receiving, ISSR, and if we can feed these portals, then it would be great, so we are reviewing that.
저희가 이제 새로 생각하고 있는 오퍼튜니티가
Some of the new opportunities that we see are flat panel antennas. We have mechanical antennas, but as you know, we need to continue to track if it is mechanical. And in order to do that, you need 2 antennas, and that would make the weight much higher. So a compact flat antenna would be a great new opportunity, especially in the midst of a growing market, as you can see on the screen.
있습니다. 예. 여러 가지 이런 드라이버는 있겠지만 특히 이제 이거는 이제 저희가 볼 때는
These are some of the drivers, but if you ask us, the costs of components would be another critical factor.
부품을 이용해서 이제 시스템 만들어야 되는데 실제로 거기에 들어가는 게 이제 단순히
We need to create components to create a system. There is electrical components, semiconductor technology as well. So we are investing in R&D.
그래서 위에 보시는
Sorry, one picture is gone.
이 위에 보시는 그림이 이제 저희가 생각하고 있는 모델입니다. 실제로
The prototypes are already out for these flat antennas. This is for fixed and changing, as well as for vessels. And since there are a lot of changes, we use stabilizers. So there are many types that we are developing. And as I mentioned earlier, technology is important, but we need the facilities. And we also need thermal or semiconductor technology as well. So we are partnering with different facilities to develop this. This is in the US. And this is the RF and test technology and SMT production line and software in our facilities. One of the other opportunities that we see is 5G NTN.
설명드렸다시피
And I did mention this before as well. We have relied on satellite services for now, up till now. But how can that be integrated with the ground telecommunications that we use on Earth?
특히 이제 그런 와중에 이제 NTN이 지금 필요나가 상당히 진행되었어요.
And right now, NTN is being standardized to a certain level. So we have to think about what opportunities that poses for antennas.
위성 안테나 부분에 해당하는 것들이 이제 게이트웨이 안테나, 특히 이제 위성의 유저가 지금 휴대폰 안테나 쓰더라도 그라운드에 서비스가 랜딩한 안테나가 이게 게이트웨이이기 때문에.
And even if we use the user interface, we need the gateway in order to know where it lands.
결국은 이런 TN가 트러스트 네트워크가 난 트러스트 네트워크의 인터페이스 부분에 결국은 안테나가
Then this antenna is needed in the non-threshold network as well as the threshold network.
이제 이게 5G 단계에서 보시면
If we look from a 5G standpoint,
이 위성을 도입하는 이유가 가지고 5G
the reason we are using satellites is to expand 5G services or extend it, or for service scalability. Therefore, when we look at the terminals that are used in vessels or ships, can use this service as well. And if we do 5G network for live broadcasting, that would still create a lot of buildup or bottleneck in one region. So if we can download HES, that would still be a great opportunity and a solution. And as a supplier, I believe that this technology will be used more in the future.
뭐 이렇게 세상에서 육지에서 올라왔다면 이제 앞으로는
Now that we've come to land from the ocean, we must go into the sky and space. I think constellations will increase and ground will increase as well. But I think we can apply the technology that we already have into these new areas. So I think multi-beam phased array antennas, beam-forming platforms, and feed-link antennas are some of the technologies I can mention. So we are also developing in these areas. So the airborne platforms, etc., are some of the areas that we are developing. If you look on the right side, we are also interested in GMDSS. We started from maritime satellites.
선원들의 임명 그리고
The entertainment infinity is important, but the safety is also very important. AIS and VDS are some areas that we want to continue to be interested in. That was my presentation. These are the products that we are developing and currently producing. Thank you very much for listening.
부사장님.
Thank you very much. Are there any questions on the ground? If you raise your hand, we will pass the mic to you. I see no hands. Oh, we do have one question.
맨
I think at the very front. Hi, I'm Kim Yong-il from Just Tech. Thank you for that wonderful presentation. And I've always been interested in your company, and I finally get to meet you, so it is an honor. SpaceX is providing satellite antenna in the war in Ukraine. And I believe this is the similar concept, and they use semiconductors as well. What is the difference, or is it the similar principle that you guys are using? Thank you for that question. The same principles are used. How are we going to do beamforming with a phase array antenna? That would lead us to many different solutions, and how we use this technology would be a different answer. As you know, SpaceX or SpaceLink uses their own technology. There are many YouTubes that look into the technology, and you can see that it is quite advanced. But in order to do that, it is extremely costly, and whether it is economic and whether it has good enough performance, those are trade-offs that we need to think about. So as I said, the principle is the same, but how do we make it marketable is another question. And if an antenna is too expensive, it is not accessible. So we have to think about what is going to make it cost-effective. I hope I have another chance to tell you more in detail. All right, thank you very much. Are there any other questions? Okay, if there are no other questions, let's give him a big round of applause. Thank you.
Right, so let's move on to the next speaker. We will hear a speech on the topic Satellite Data Reception Processing and Space Ground Station. We will hear from the CEO of Contech, Lee Sung-hee. Please greet our speaker with a big round of applause.
CEO of the Contech. It is really an honor to introduce the Contech's profile and Contech speech in here. Contech is the spin-off company from CARI, Korea Aerospace Research Institute, because actually I just worked for CARI for 16 years. After that, I just made my own company 8 years ago. Nowadays, we just provide the GSAS service and cellular image processing and application service. We just provide the whole vertical chain end to end for the downstreams. So we have, at this time, we have 73 engineers for contract. So also, our headquarters is still inside the CARI areas. We have our subsidiary in Luxembourg. Yesterday, I had a lot of meeting in Luxembourg delegate in the Four Seasons Hotel in Ulchiro. So yeah, it is quite a meaningful business meeting with the space, the commercial company in there. Actually, we have complete our whole series funding from A to C with $65 million US. I think that we just expect to make our revenue this year more than $15 million US. Maybe next year, I think that we have more than 2 times than this year's. Another our event next year, we have a plan to list up our company on the Kosdaq market Q3 2023. So after that, we will make another our subsidiary companies like the Contech Launch Service and Contech Space Optics. Nowadays, we have 2 companies, Contech Earth Service and Contech. Contech is a mother company. Contech Earth Service is subsidiaries like the daughter company. Yeah, this page, it is quite the interesting part. As I told you, we just provide end-to-end service. When we receive the satellite operation company, when we receive the data from the satellite operation company, we just used our ground station. It's like we just provide the GSAS service, ground station as a service. That it is just a raw data receiving. After that, we just applied our radiometric, geometric, and spatial algorithm to get a well-defined processing data. After that, we just applied the AI deep learning algorithm to provide the satellite analytics service. We just provide the end-to-end service for whole downstream. Yeah, we have already whole technology 100% by context. Here is our customer, the KSA, North Space ISI, also MEXA, the RV Signal, AST Mobile. Anyway, we just provide the context, the ground station service, as well as the satellite image processing. I just explained the one by one. At first, I just explained the more concrete exploration for the ground station as a service. When we contract with our customer, we just get the trajectory data from the satellite. We just insert the satellite trajectory on our scheduling system, and then our ground stations will be operate. After that, we just store whole data in our data server. Next year, we will store the whole data at the AWS cloud. For this reason, we are now the interaction with the AWS to use the AWS cloud. We will also load context satellite image processing algorithm and application algorithm on the AWS cloud. In that case, we can provide the whole data receiving and application service within 30 minutes. Actually, based on my experience, last IAC and WSBW, I had a lot of the panel discussion. Several bits of our customer is quite interesting to provide the whole data service within 30 minutes. Nowadays, fast data delivery has gone from hours to minutes. That is trend. So we have to think of that when we provide the downstream service. That is keep in mind. Here is our ground network. We already complete the Alaska and Finland, the Sweden Islands, something like that. Also, we will implement our optical ground station. First, OGS shall be installed in Western Australia, nearby Perth area. The second OGS is in Qatar, not Qatar, in the Jeju Island. Actually, Jeju Island is not good. Actually, for the radio communication, the weather condition is quite important things. Because actually, during the radio communication, we have to avoid any other the rain or the snow or humidity. So for this reason, actually Jeju is not good area, but we needed to make the demonstration test. In this regard, I just decided to make the second OGS in Jeju Island. But anyway, third OGS in Qatar. Qatar is a great area. Now is a World Cup, right? So okay, fourth area is New Mexico in USA. Anyway, we just provide OGS service. In order to make this kind of service, nowadays we just interaction with the Workspace in Japan. Workspace, they just make the LEO and MEO communication satellite with the IS, with the radio communication, the way. So anyway, nowadays we have the potential customer for the OGS service. Yeah, here is our first ground station in Jeju Island, the Alaska and the Ireland, the Sweden, South Africa, North Space, something like that. When our customer use our ground station, we can provide the 70-minute, it's like the revisit time for the ground station. So it is quite important thing to provide the 30-minute data delivery and processing. Here is the OGS block diagram. Also, as you can see, we have a lot of our ground station area. In there, we already have our RF ground station, and will be installed the OGS, as well as the SSA telescope, space spatial awareness. So in order to provide this service, we already made a partnership with the Digantara or something like that. They just installed their SSA telescope several areas, and then we just use their platform. So when we contract with our customer, we just provide the GSAS service and the OJ service as well as SSA service. Here is the level 2 service, satellite image processing. So when we receive the satellite raw data, the raw data is not good. So there are a lot of the noise, a lot of the geolocation is not good. In order to make the well-defined satellite image data, so we just applied the radiometric, geometric, and spatial algorithm. After that, we can get the well-defined standard satellite image data. We already contract with the CARI to provide our Carrier software for the COMSAT 3S, 3A, CAS 500, and upcoming COMSAT 7. So we also contract maybe 2 months or 3 months ago for the another small satellite project. Yeah, last thing is level 3 satellite image application service. With the standard image data, we just apply the AI and deep learning algorithm. After that, we just provide the several kinds of application service, such as the smart city and harbor monitoring, disaster or agriculture, something like that. We already provide the smart city solution for the Seoul government, Seoul local government. Also the, I don't know the English name, the Busan 항만공사. Also, we just try to make the potential project with the Jeju local government. Here is another commercial part. I think satellite image application service, for the satellite image application service, we only focus, most of the world, the company just focus on the B2G and B2B. I think B2G, B2B is not good. We have to change our mind. In order to raising up B2C service, we have to think of the which kind of the industry, which kind of the technology will be merged with the satellite image application technology and data. So in this regard, I just think, okay, if we just provide our satellite image data for the NFT or education, space art, I think that we can raising up whole satellite image applications of for the consumers. It's like the B2C. So for this reason, we just already interaction with the Korean local the Metabus company, also the Japanese company. So we will maybe, I don't know, at the end of the next year, we will provide the whole solution on the mobile. But end of the next year, I think that you can get this kind of service on your smartphone. So that is our upcoming new project. Okay, last thing is our future plan. So yeah, the step 1 and step 2 is already done. Now is the context is on the phase of the step 3. We will launch our 2 satellites. One is the EO satellite with the 16U size. We already contracted with the Nano Avionics to get the 1.5 meter resolution satellite image data. Also, we just contract the Space Luxembourg to launch the C-band SAR satellite to get the 0.5 meter resolutions. We just invest our money around the $20 million. So end of the next year, 2 satellites shall be launched to get the whole our ownership data. We will store whole of our SAR and EO data in our data server, and then we can provide the whole data to our customer. Yes, actually, we already get the LOC, letter of commission, from our potential customer to sell our data with $10 million. We already secured our revenue with the $10 million. Also, in the Jeju Island, we will make our space park. I just called the space park operated by Contact. Yeah, we will next, and I don't know, actually maybe middle of the January, we will start to construct whole of our the space park, to build up our antenna farm. We just provide hosting service for KSAP and Leap Space, also Diganchara, stuff like that. We will install more than 10 ground antenna in there. Also, we will make the mission control center for the launch mission and satellite operation mission. Also, another thing is the OGS and the Space Education Center. I'm really interested in the raising up the space education for the normal people and the student. So we will provide whole of the solution to understand the space industry, space technology. Also maybe, I don't know, the Q3, the last Space Tech Expo conference, I had a meeting with the Space Ride in Canadian company. They have the plan to launch their first commercial launch service Q2 next year. Also Q3, they will bring their launch vehicle in Jeju Island. So we will launch the Space Ride launch vehicle. Space Ride launch vehicle is quite interesting, the launch vehicle. They just lift up their launch vehicle with a big balloon up to 30 kilometer altitude area. After that, the launch shall be ignition, make the ignition, the SSO and inclination orbit. As I know, for the SSO mission, the payload, the capability of the payload is around the 150 kilograms. So anyway, we will make the showcase with the space ride in the Jeju Island. Another project is a spaceport. I had several meetings with the Sierra Space. As you know, they just launched their Dream Chase space shuttle from the Florida to their commercial space station. But after that, I just suggest they can land the Jeju Island when we make our spaceport. So in order to do, actually, I have to get a lot of the support from our government to get a license, also any other support. But Japan government is really interested to make their spaceport. Now the Japan government is just moving. But in South Korea, only Contact just moving. So we have to, our government and commercial company like the Contact, we have to make the feature how to raising up Korea space industry with the other partners. So for this reason, actually, I already contacted the Jeju local government, but I don't know actually at the time that I didn't get any response from them. But anyway, I will just try to make the spaceport with Sierra Space. That is our upcoming big project. Yeah, that's it. I have still 6 minutes. If you have any questions, please feel free to contact me.
Thank you very much. It was like listening to a visionary. 네, 일단 정말 영감을 주는 그런 강연이셨던 것 같습니다.
I think that was a very inspiring presentation. Thank you so much. So will I be able to get the video on my cell phone next year? Yes, I think it will be possible. I think the size of the video would be the biggest issue, and we're trying to solve that. Thank you so much for that inspiring presentation. Do we have any questions in the conference hall? If you have a question, please raise your hand.
지금 보이진 않고요. 그럼
Looks like there aren't any questions, so let us finish this session. Please give him a warm round of applause. Now I'd like to invite the third speaker. This is Felix Steiner. He is the sales engineer from Yuri Lux. He'll be talking about microgravity research beyond ISS, a chance for countries like Korea. Please welcome him with a round of applause.
So, good morning.
안녕하십니까, 여러분? 저희 유리를
Chance to give a speech here in this forum. So, I am going to talk about today about the microgravity research beyond the ISS and a chance for countries like Korea to do scientific research in the low orbit. So, I directly brought an image which we took 2 weeks ago in Virginia, where we had our last mission to send up scientific experiments to the ISS and into the low orbit. So we are Yuri, and our vision is to become a category leader for space biotech and supporting our partners all around the world. And why we do it? Because we love it. So we are a team of 35 space engineers and at least 8 biotech engineers from an international base, and we are based like 50% in Luxembourg and 50% in South Germany, and we have experience of 30 plus years in working together with NASA and the ESA and also the German Space Agency. And as you all know, and that's also why I am talking today about this topic to you, we know that the ISS will come to an end in 2030, and we will take a look today on the opportunities which are coming with this end of lifetime of the ISS, and we want to talk about how we can create together breakthrough biotech products in space. So, where do we see benefits of life science and using the microgravity in the low orbit as like an enhancer of this process? So we have here like different biological or life science areas where we can use microgravity. So we are talking on the one hand about protein crystallization we can use for new drug discovery and drug delivery. Then we are also taking a look on organoid growth in space to have a more efficient drug testing and get also rid of animal testing. We can also take a look on stem cells to accelerate the regenerative medicine on Earth. And we can also take a look on cancer or on any diseases in space, which will have a faster outcome in space. And how are we doing this? So at the moment we see that the ISS is fully packed with facilities. We are having hardware and are able to send it up to the ISS in any facility on the ISS at the moment. That's how we can get your life science research from institutes in Korea to the ISS at the moment. But as I already said, ISS will be closing. So there we developed the science taxi. This is at the moment in development and will fly in 2024, Q1 2024 with Aerospace. I will come back later to it. And there we have the opportunity to not only go to the ISS until 2030, but also send up science up to different orbital platforms, which are coming in the near future. So, and how are we doing the end-to-end process for your institutes in Korea and for the universities in Korea, or for any other company we can do like life science research and manufacturing in space? So at the beginning, we define the experiment together. Then we from Yuri define the hardware and the bioreactors together where we do these experiments in. Then during the year, or during the process, we do all the certifications, all the trainings with the scientists together, and the scientists can just concentrate on their experiments and their further process in doing their science at the university, for example. At the end, we do the final assembly before the mission, then we execute the mission, send up the science to space, and we will do all necessary steps to get it back, that all science and all the manufactured bioproducts which are manufactured then in space can be analyzed afterwards. And this is like, oh, sorry, I have to go back. This is like the costs and the timeline we had in the past. So when we used the process within using space agencies, we had a timeline of 2 to 5 years, which is pretty long, and the cost starts at €1 million. And as we are commercialize the new space industry, we brought it down to starting at 6 months and lowered the cost from starting at 100K for the first experiment in space. But where can microgravity research start with us? So we are having also the opportunity to work before we go into space on a simulated microgravity base. So a simulated microgravity works on cells and also on plants. So therefore we have this like URI RPM. This is a scientific machine which is used since more than 20 years in the scientific world to simulate microgravity and do the pre-tests on Earth. So there you can see it on the image. We can simulate different types of microgravity, so like also lunar or Mars gravity for the cells. And we did also our own experiments on this machine, and it really stimulates the cells that they're really thinking they're in microgravity. And after you have a working project on a working experiment on the simulated microgravity, you can go get some new funds and go into space. What we can also offer to the Korean scientific network is our global network of scientists all around the world. So we are working together with universities in the US, like the MIT, but also with universities in Australia, also in Singapore, and of course, all over, and of course, all over Europe. And we would like to share this network with your country and with your scientists. And then we're talking about what's coming beyond the ISS. There we already saw a presentation from Blue Origin, which presented the orbital reef, like having future space platforms and space vehicles. And we are at the moment partnering and putting up corporations with different space vehicle providers which are coming in the next few years and having the maiden launches coming from 2024 to 2025 and 2026. And there we are talking a lot with US companies like Blue Origin, with the Orbital Reef, Sierra Space, with the Dream Chaser, where we will have the maiden launch of our science taxi, then Inversion Space. But also we're talking to a Japanese startup. They are sending up their returning satellite in 2026, and also to Axiom Space. But as well, we are talking to a German startup. This is like the exploration company. We have payloads on it and on the Nyx capsule. But this is just a small example of what's going on in the new space industry and in the industry of new space vehicles, as we're talking to 20 to 21 companies at the moment. But let's talk about our science taxi. This is the first itself space incubator which will be outside the ISS. And it will give you the chance to host up to 38 experiment units, move out of the ISS, go to new spacecraft vehicles, and you can work completely independent from the ISS on a commercial base. The science taxi will work in a temperature range between 4 and 40 degrees, and it can run completely autonomous. So there's no crew interaction needed. When we together plug in the science taxi in the spacecraft, the experiment will directly start, and the timeline can be shown on Earth, and you can also have images down to Earth from your experiments. What's coming with the Science Taxi? These are our modular science shells. These are our reusable bioreactors. Yeah, I hope you can see it well on the image there. So we have different types of such science shells where we put in together with the scientists, for example, of Korea, the cell experiments, but also possible for plant experiments and small animal experiments and crystallization. Science shells, of course, where we will have a modular design that we can adapt it for each scientist, what he wants to have, different type of tanks for the cells, for the media to refresh the cells. And we can adapt it as we will 3D print the parts for it, and we will also attach a microscope into the science shells that all scientists can watch their science down from Earth while it's growing in space. So, I just want to say you that let's make history together. So we are having the main launch of the Science Taxi in 2024. And we would love, so we are already in contact with some universities out of Korea to talk about simulated microgravity. But if you're interested to go directly into the space or onto a new spacecraft in 2024, then we would love to get in contact with you and talk about future opportunities in space. And here's just an example how this process will work, for example, for the maiden launch. So we will have like a contract signature in Q1, Q2 2023, and then we start this end-to-end service project during the year. We will have trainings in mid and end of 2023, and we'll have the mission execution and the final assembly in Q1 2024 and Q2 2024 when the launch will be executed, and we will then have the mission will last 30 days, and we will have a return after these 30 days to analyze the samples on Earth. So once again, thanks for your attention. So we would love to do space, life science research in microgravity together, and we can start now. Thanks a lot. We also have like small brochures in the back, and if you are interested to talk more about it today, we are here until end of the day. So we also, here's the co-founder of the company. So we are two. If you're interested, just come by and let's have a chat. Thank you very much.
Thank you very much for the speech. 혹시 현장에 계신
Does anybody have questions in the conference hall?
네, 감사합니다.
Thank you very much. Please give him a big hand. So next we have an online presentation. Martin Ekdahl from Kuva Space, the Director of Business Development, will give us a presentation on powering climate change mitigation and security intelligence using hyperspectral nanosatellites and advanced deep learning analytics. Oh, he is here with us in person.
되겠습니까?
Give him a big round of applause, please.
Thank you, and good day, everybody. I'm very honored to be here, and I would like to thank the organizers for the opportunity to present here and tell you a little bit about how Kuva Space is planning to help us with the climate change mitigation and in the new degraded security environment that we currently face. And as said, my name is Matti Ekdahl. I could say I'm a veteran of the Finnish satellite industry. Kuva Space is based in Finland with Moomins, Santa Claus, and a company called Nokia, if somebody still remembers. Here's a picture of me with our hyperspectral satellite. So it's 12 6 to 12 units in 2 different generations. So it's a nanosat satellite platform. And space is often combined with future, but I'm going to go the other way first. I'm going to go into history, because I think in this context it's important. So every now and then, humankind creates inventions that become much greater than the invention itself. And there are a few imaging technologies that have been able to transform the entire perception we have for the world we live in. Let's start with roughly 100 years back from X-ray imaging. Obviously, it had a revolution in the medicine. This is not the topic for today. But soon after that, after inventing X-ray imaging, we found out that there's a thing called radioactivity. And soon after that, we figured out that all matter in the world is comprised of atoms. And therefore, this changed the entire understanding of the universe and the world where we live, and it led to breakthroughs in many scientific fields. Telescope 400 years back, not imaging per se, but falls under the same category. Confirmed the heliocentric model of solar system. We found the gravity later on, or confirmed it. And we started understanding, it was the baseline of our understanding for the cosmos, for the universe. Once again, changed the entire understanding of the world where we live in. And why am I talking about this is, I think the point here is that to be able to solve fundamental great problems, we need to understand the mechanisms behind. And if we want to heal the Earth, we need to understand thoroughly how it works. And Earth happens to be a very complex environment, as we know. And just today in the newspaper, I read that we are facing a loss of diversity, and the scientists don't really yet know how this will impact life on Earth. We just don't know. So it's hard to make the right decisions if you don't know how things work. And this is what we believe at Kuva Space that we can help with. So we believe the next big thing is consistent daily hyperspectral imaging that can provide us with new kind of information and intel. This is a typical optical satellite image and what we can say from it. Of course, with advanced analytics, we can say a bit more, but this is the baseline. We can say that there's forests, there's fields, and there's something else. And we want to take this to another level, to be able to understand how the delicate ecosystems actually sequester carbon or release methane, what's the net worth of that, how does the ecosystem work in long term, in short term. We can identify species, so basically we can quantify and identify whole Earth, and this enables a lot in fight for the future fundamental problems we are struggling. Our solution is to build a constellation of 100 hyperspectral satellites, and this takes us to roughly in the capacity of imaging the whole Earth 3 times a day. And this sounds a lot. Why we need this? I'm going to come back to this later. Instead of delivering our customers with raw data, we will be delivering end solutions. So we are applying artificial intelligence algorithms and deep learning on top of our data and deliver our customers with services and solutions. Even though we are a new space company, we already have some satellite projects under our belt, and we have built 3 first in the world nano satellites. So we have delivered the first hyperspectral nano satellite in the world back in 2018. still working, by the way, so it's a pretty good proof of concept for us. W cube was the highest frequencies transmitted ever from space, built for European Space Agency, as well as Sunstorm, a most advanced X-ray spectrometer in orbit. And let's go to the solutions and services a bit. So most of us know that there's a thing called voluntary carbon credit markets, where companies can compensate their carbon emissions by funding projects that sequester carbon from the atmosphere. The problem here is that there is no verification. Nobody really knows how much carbon is sequestered in these projects, or what's the long-term impact on these projects. Do they even survive 10 years, 20 years, and so forth? And this is what we want to change. This is a huge fundamental problem. I have come up, or I bumped into this sentence that stated that we have to take care of the carbon problem, because if we don't, ultimately carbon will take care of humans. And we can already see this impact in our lives. There's a lot of floods, there's a lot of droughts, heat waves, all kinds of unwanted climate things, and we have to mitigate this in the next 10 years. So how can we help in this is that with hyperspectral data, we can actually quantify how much carbon there is on, let's say, seaweeds. This is a seaweed example, but could be peatlands, grasslands, even agriculture, you name it. But in seaweeds, there's a lot of potential, because seaweeds deliver the carbon into the seabed, and it's very stable storage for carbon. And there just isn't enough data how this actually works and what are the volumes and so forth. And we have currently ongoing projects, field trials on this to study this mechanism further. But the problem in like how we can get companies to commit on this kind of project is that we have to make it transparent for the companies. Now some large companies aren't really doing this kind of carbon credit things, because they have no idea how their money is spent. Is it actually making good things for the climate or not? And some other companies are overcompensating just to be sure that they are going to the zero carbon direction. So this is a major issue. If you have the verification, the whole value chain starts to work. Sorry, wrong button. And then another aspect is improving food security. Maybe some of you noticed in the news, I think it was just a week ago, 2 weeks ago, it's 8 billion people today on the planet, and it only took 12 years to go from 7 billion to 8 billion. And at the same time, we are facing worsening climate conditions, more storms, droughts. So it's going to put more pressure on the food production. And here, one thing we can do is yield forecasting in global scale. So hyperspectral data is capable of identifying crops in different growth stages. As you can see from this graph on the left below, there's spectral fingerprints of different crops. So each crop has a different kind of pattern and can be identified. And when you apply this with 100 satellites imaging the Earth every day, you can track and kind of forecast how much hectares there is wheat, soybean, and so forth. And when you use data fusion and add other data on top of that, you can get closer to the idea that what's the actual mass, biomass that will be produced on wheat, for example. Crop health, obviously important thing here. So we can say a lot of things about the crop health and nutrition, if it's lacking something, if it needs to be irrigated, if it's suffering from pests or diseases, we can early detect this through the daily data. And we can also say what's the optimal plantation time, harvesting time, and so forth. And this all leads to better and higher yields. This is a case study around it. We did this with the Finnish Food Authority. So there was a expectation of 50,000 hectares of spring cereals to be planted by March 2020. And this was according to the farmers' announcements. And we only had one image, hyperspectral image, over the area that time. And using our algorithms and deep learning, we had a 91% accuracy in the crop identification. If we would have had 2 or 3 images, it would have been very close to 100%. Just to kind of summarize the climate change impact we can have is to help understand the net carbon emissions. I think the net here is crucial. There are many assumptions in the carbon markets, and we want to change that to be more transparent and truthful, and enable verified carbon markets to work, optimize yields through precise data, and help major corporations achieve their zero carbon and ESG policies faster and cheaper. And then let's switch topics to the security environment a bit. Especially in Europe, the environment has changed a lot. In the Korean peninsula, you have a different kind of challenges than us, but the common thing is that in this sense, the world seems to be going in a wrong direction, from my opinion. I would have liked to seen it go to the very opposite. But hyperspectral satellites and hyperspectral data can help a lot in analyzing what's the state in the environment we live in. And here's a quite interesting case study of the hyperspectral capabilities. So everything on Earth has a kind of fingerprint type of an hyperspectral identification. So my hyperspectral fingerprint would be different than the previous speakers. So we could be identified from the mass of thousands of people. And with the same idea, we can identify ships, for example. So we can track individual ships throughout the seas. So if we have once identified that this is a ship A, and we put 10 different ships around it, we can still track the A ship moving within the other vessels. Monitoring seabed is quite interesting. The only bad thing is that works in shallow waters less than 25 meters, so in coastal areas. But you can see the seafloor and kind of automatically detect changes in the seafloor environment. And this, of course, enables more efficient uses of other resources like patrol vessels, ships, or high-res optical satellites, SAR satellites, and so forth. And last is, this is kind of summarizing all of our technologies, so hyperspectral data, AI deep learning algorithms, and kind of automizing the whole process. So one key thing in hyperspectral data is that it is very good in differentiating between natural environment and human-made objects. And we did a test with modern camouflage nets that are used to hide objects by the military. And from the visible data, it was very hard to see those camouflaged objects because they work very well on the visible light spectrum. But on the hyperspectral spectrums, when you have 250, 400 bands that you can use, they will, like in the bottom left picture, you can see that they are kind of like bright spots on the black image base. So they have such a huge contradiction because they are synthetic materials. They are not tree leaves. They are not grass, like the environment where they sit. And this is obviously a quite good tool for situational awareness in a large scale. end of my presentation. I thank you very much, and it was an honor to present here today.
Thank you very much, Director Matti Ekdahl. So it was really encouraging to hear how Akuba Space is providing the much needed solution to mitigate climate change. 여러분 혹시 현장에 계신 만큼 질문하고 싶으신 것?
Does anybody in the conference hall have questions? Okay.
저희 세션에
Now we have the last session of our morning. We are going to ask Mr. Kim Il, CEO of Satric Initiative. He'll be talking about high-resolution Earth observation business, focusing on utilization. Please welcome him with a big round of applause. It's my honor to come back to the Korea Space Forum to speak. Thank you so much for inviting me. It's a very interesting session. If you look at the developments in the space sector, don't you feel there's a lot going on? Including my training years, I've been in the field for 30 years, and it's quite a dizzy and very dynamic time for me as well. As you are well aware, this year as well as last year has been a very historic year and years for Korea as Nuri has embarked. And now, as we open the new space era, the president has announced the space economy roadmap. There are a lot of news articles mentioning that space governance is one of the critical pillars that our government will look into. And we know that the Korea Aerospace Agency will also be established soon. 2020 also marks the 30-year anniversary since Uribyul, the first satellite of Korea's, was launched. You can see the young people in their 20s who created the satellites have become the people here you can see on the bottom picture. I'm one of the first generation space specialists, and I want to thank all my colleagues for their efforts as well. We are facing crises and challenges, and we have to prepare our future generation. I think this is a very transitional time for us. These are some of the areas that, well, Earth observation is the area that Satric Initiative is focusing on. As you can see on the slide, our global space market in 2021 is 337 billion. Each institution will have slightly different numbers, but I believe this is the overall number. Upstream takes up 11% and downstream 89%. In a global market of 440 trillion won, we only take up a small share, and I believe all of you here are very well aware of that. The Earth observation market takes up only 5% of the entire space market. And it is very different from the telecommunication industry. The downstream industry is much bigger. This is because governments purchase a lot of satellites traditionally. And we did mention in previous sessions, but the B2B and B2C markets are not yet fully open. So the navigation or telecommunication industry holds a lot of potential. The EO market has grown very steadily, and it will become 80 trillion won. And as I said before, the public or government takes up 90%. And as you can see, this number is going down. That means the private sector is taking more leadership in this market. And that applies for the EO market as well. And if you see on the right as well, this market will continue to grow. The defense and security market is still the biggest, but you can see that other markets will grow in comparison. I believe the natural resources and infrastructure industry will grow. Finance and location-based industry also hold a lot of potential. And as mentioned before, new space has become a common word in our vocabulary in Korea as well. Nano satellites are also of people's interests. I do not believe everybody needs to be interested in this area, but if we look at the weight of the satellites that have been launched, you can see it in the graph. The 600 kilogram or less small sats are displayed in blue, and the rest are in gray. As you can see, small satellites have been explosively growing in the past few years. But taking away one lap satellites, it's difficult to say that the overall market is growing in small sats. And you can see that the need for large-scale satellites are still there. The usage of the satellite determines the size of the satellites, and I don't think small sats will be the silver bullet for all of our problems. Let's take a look at the evolution of Starlink satellites. As you saw in the news, Generation 2 satellites have been in production, and it's 1.2 tons probably. And if we compare that to the first generation satellite, it will be 2 to 3 or 5 times heavier. And this has been in line with Starlink's plans to increase the mega constellation. Starlink has looked into the needs of the market and evolved accordingly. Chad Anderson also spoke of something similar from Space Capital. The SPAC market is really gaining a lot of attention. Planet, Satellogics, Spire, and Black Sky have become public through SPACs. New space companies are showing their financial performance through SPAC, and you can see it apparent in their stock prices. And the presenter also said that the revenue is growing, which is great, but we have to look at the operating profits. What really drew my eyes was on the right. If we look at Planet's revenue structure, which is a company that has proclaimed they will go into the small satellite industry, you can see 25 plus 36 is almost 60% is taken up by non-governmental entities. So if I try to summarize what I'm trying to say, we have to look at what satellite we need, what kind of data we need, and what service we need. Those components are decided by the market. The potential of downstream markets is big, but it is still early. Third, I want to emphasize that the role of the government and the public will remain important in EO. I'm not sure if you will remember this because it was 2 years ago that I spoke of this. Many people said it is private-led, but I think it should be private and public-led. In order to show you the importance of the public sector, I want to give you an example. A lot of people said that NASA has contributed to the development of SpaceX, so I won't mention that anymore. But let's look at the national space policy of the United States of America. Let me read you from it. It says sustainable, robust, that commercial space capabilities and services need to be purchased, and they must prioritize partnerships with commercial industry to meet government requirements. And they must consider inventive, non-traditional arrangements for acquiring commercial space goods and services to meet government requirements, and refrain from conducting government space activities that preclude, discourage, or compete with commercial space activities. Well, another example that I want to give you is in regards to the satellite data sales, usage, and storage value chain. MaxIA is a company that is in this entire process. There have been M&As, and so the name of the company has changed, but let's think of it as one entity. EO specialists will know that it started out as a clear view and next view, and then it advanced into enhanced view, and then EOCL. They have taken advantage of the data services and the US government to develop to the next level. And the contract amount will be 4 trillion, 2 of which is by contract and 2 is not a fixed-based contract. Now let's look at the press release in regards to this. The National Reconnaissance Office of the United States said that the Planet and Black Space are some of the companies that have been included in the contract. And you can see is 1.3 trillion including options. You can see the numbers that have been contracted with Maxar and BlackSky. Interestingly, Planet has no information on option contracts. This contract shows that the US government has tested the EO data needs, and they have transferred those needs into an actual contract. The NRO also had 6 RFO location companies come to an agreement on the learning terms. And I believe that we will go beyond this field of engineering into other fields. Celltrack, our company wants to lead in many areas other than just location, etc. We have expanded into different business fields. We are not just a satellite company. We want to look at utilization so that we can help commercial companies. This is an example of an object identification created by one of our affiliates, SIA. It is looking at the vessels in the ports. AI is old news, isn't it? It's mentioned very much, and I think a lot of people already mentioned it during this session. One thing I really want to emphasize as the CEO of my company is that our technology is actually used in the field. We are developing a 30-meter satellite. We are going to launch our satellite in 2024 as a part of the Falcon efforts. After we launch the satellite, we are going to receive high-resolution data and analyze this data to provide it to the market. Utilization and distribution of high-resolution EO is one of the main goals of our company. I believe my presentations were not as robust as the other presenters. This is the same slides as 2 years ago. And this is one of the last slide that I used previously as well. Public-private partnerships take many different forms. However, the core is to create competitive companies and for governments to use these services is a very important goal of PPP. Reestablishing governance, space roadmap, and the vision for the space for Korea are all important topics that we have discussed. As we prepare the future generation for the next space development, and as someone who has been in the industry for 30 years, I am very excited about the government's direction. With a diversification of space development through PPP, I believe our companies can become a robust, strong companies in the global arena. I have a few seconds left, so there is a pitch. Unistella and many other companies are making their pitches. So please stay tuned. Thank you.
Thank you very much. As always, long-term insight is very important. Thank you very much for your great insight. Does anybody in the conference hall want to ask a question? I believe that we're all hungry. Yeah, it's lunch now, so. Okay, so this will wrap up our morning session, and we will have a lunch for 90 minutes. We have prepared lunch boxes for you, and we have enough to go around. You can just stay in your seats, and our staff will bring you all of your lunches. So enjoy your lunch. If you need a spare, or if you want more after a lunchbox, then please request one. Have a great lunch. I hope you all enjoyed your lunch. Now let us begin our afternoon session. First, we have the fourth keynote speech in store for you. Our lecturer, Kim Sang-don, the country manager of Starbust, is here with us. He will present us with a presentation on the global trend outlook of startups. Please welcome him with a big round of applause. Good afternoon, everyone. As introduced, I am Kim Sang-don, the CEO of Starbust Korea. Today, I want to approach my topic with a global perspective. We have a lot of speakers waiting to speak after me, and we have a lot of promising startups here. So I'll focus my speech on how innovative startups are in Europe and in the US, so outside of Korea. So I think that you might not be familiar with the name Starburst. It sounds similar to startup, right? So to give you a little joke, there's times when Starburst is autocorrected to Starbucks a lot of the times on the internet. But I want to make it clear we have nothing to do with Starbucks. We focus on accelerating and investing and consulting in aerospace defense industry startups. And our base is in the US. I am in charge of the Korean branch. Aviation and space and defense. 38. So these numbers are cumulative numbers. There's 38 aerospace unicorns. So startups with more than 1 trillion won's worth of company value. Unfortunately, these are global numbers, and Korea does not have a unicorn in aerospace. I don't want to be very specific here, but out of the many excellent startup pitches that we heard this morning and yesterday, I heard that we will see some Korean startups be listed on the market. So I hope that going forward, we also can see some Korean brands here. So what is the space sector? There's a lot of keywords like launch vehicles, space exploration, deep space research, and antenna-related companies, as well as components, parts, materials companies. So let's focus more on space startups. On the left, you see the number 38 unicorns. Now, half of these 38 cumulative numbers are taken up by space startups, mostly startups from the US or Europe. And this year, due to the Russian-Ukraine war, the aviation industry has stagnated quite a bit. But as you know, of course, money flows around the industry. And this year, rather than the aviation industry, defense industry has seen a great boom. And of course, space is closely related to defense, so I see a promising future for the space sector. I also want to stress here that in the past, it took about 15 years for startups to become unicorns. But recently, that time period has been shortened to 3 years. Going forward, I hope that many Korean startups can also become unicorns. I'm not sure if you can see the map clearly. It's a map of the world. Now, one area where Korea could do better in is that there's not a lot of startups, unicorns in Korea. It's because out of the 38 unicorns, 78% are US companies, and more than 50% have their base in California. So in one state, the state of California, there's a lot of venture capital in regards to defense and aerospace. So the US is leading this sector. And right behind the US, there's Europe. And also, China is focused on supporting drone-based and aerospace-based startups. So before I tell you more in detail about world startup trends in aerospace and defense, In Korea, I think people think of startups as entrepreneurships with less than 10 employees, but actually the core keyword of startups is entrepreneurship and uncertainty and the spirit of taking on challenges. So innovation is a crucial keyword, and innovation always comes with risks. If we think of SpaceX didn't start as a startup in Korea standards, but startup faced numerous challenges and failed about 20 something times. The company overcame those numerous challenges and now is focusing on transforming Mars. So basically, at the crux of startups lies the spirit of innovation and challenger spirit. So let me focus more on the space sector now. When we say the space sector, we have many space experts here, but many people, when they think of space, just think of it as a very big, wide, undefined place. And it's true, of course. The solar system itself is very big. But the area that we can utilize is very limited in space. Recently, there's been a lot of conflict around orbit, especially low orbit. And this isn't talked about frequently in the media, but James Webb Telescope is located now in Lagrange Point. This was something that NASA did. Sharing information with mankind is very important, but from a strategic point, it seems like the US has already reached into the Lagrange point and expanded their reach there. Also, there's a lot of radioactivity in the space and microgravity and vacuum in space, which can all be utilized in research sectors, and also which shows that space is a very dangerous place. And also, this is a topic that often comes up, especially with exploration of the South Pole. But if a man lands on the moon, which country does that moon belong to? That's also a debate that comes up often. So we want to see more countries take on space exploration. So what is the realm, the boundary of space economy? That definition depends on who defines the space economy. Some say the space economy is more than $400 billion, $300 billion. Now, launch vehicle market doesn't take up a large portion, but there's other related parts, materials, manufacturing, technology markets that are all related to this industry. So which areas should startups head into? I think we heard a lot about this already from various startups, so I'll briefly skim over this part. Space waste is one area that startups can focus in, and also moon exploration. I think we have a lot of startups pitches waiting for us, focusing on moon exploration. Also, we could focus on space production, and also commercial space station is an area that many startups are focusing on, with, of course, the US at the fore. And asteroid mining is an area that startups could focus on. And there's a lot of base technologies that support this. Sensors To name one, which Korea also has great strength in, cybersecurity is also a very crucial area. Not many people really focus on this, but in UAM, cybersecurity is very important. If an unmanned vehicle is attacked, then that could be a great threat. So cybersecurity is very important in that aspect. For Korean startups to succeed, STEM, science, technology, engineering, and mathematics subjects are very important. I feel like when we see Korea on a global scale, we are lagging a bit behind in mathematics. So I think that's one subject we need to improve on in terms of talent nurturing. So let's look at one by one very briefly. The companies that I'll be introducing here are startups that may be very unfamiliar to people in Korea. Because we are a latecomer to the space industry, we need to take a look at these pioneering examples and take the fast follower approach. First is satellite service. Every time in SpaceX, when hundreds of small satellites are shot up to the sky, to the space, there's a lot of environmental degradation. So basically, this startup uses the last mile delivery service idea and applies it to the satellites in space. It became a unicorn last year, and with this at the lead, companies like Starfish took a step further and decided to dock on satellites at the end of their lifespan to inject fuel. And now there's the problem of inhibiting the space for a long time. So habitation and life support is important. To support this, Interstellar Lab, which is a startup in France, decided to develop a biopod because the space industry was growing exponentially. So a habitation-based biopod was what Interstellar Lab developed. And for propulsion, you might think that we have a lot of startups in Korea in this sector, but let's take a look at these examples. The first one is a company that focuses on electric propulsion. So module-style propulsion device. And then there's also Hyperspace, which is a French startup. It's a hybrid propulsion device which uses both solid and liquid fuel. Now, many people said that this wouldn't be possible and didn't even focus and didn't even try researching this. But Hyperspace is a company that is leading the sector. And this can be done at a low cost. Next, we have space debris. You might think of getting the waste, the debris in space, and then moving it to another space. Now, we have to focus on who's going to track all of the waste floating around in space. What are we going to say? There's debris heading towards your orbit, so watch out. Now, this is a privateer, a startup that focuses on sending information regarding to space waste. Next, we have commercial space station, which needs a lot of capital to begin with. That's because we have to basically carry a house into space for people to even live for a few days. So this is what the US and Europe are focusing on, and it's possible because they are the pioneers of this sector. And we will establish KASA in Korea soon, and we will have more support for startups in Korea. And by that stage, I feel like Korea will also be able to research more in commercial space station. Acting on our words is very important. Now, the top 3 companies in commercial space station are Axiom, Nanoracks, and Orbital Reef, which have great capital and also employees from NASA. Next is Earth observation. There are a lot of promising startups in Earth observation in Korea as well. But what's unique here is, well, as for orbital sidekick, it focuses on analyzing hyperspectral imagery from space. In the US, there's a lot of gas lines, gas pipes. So technology was used to find micro leaks in gas pipes. And that same technology accumulated and was developed further to be used in areas like agriculture and many industries. And it now is being utilized in space, as you can see here. In terms of precursor, it's weather forecasts in space. I saw on the news in media that a lot of data is accumulating in this startup. There's cases when movements of the sun relate with earthquakes, and once we use this data well, we could predict earthquakes before they happen. So this is an idea that they are working on as well. Now, last but not least, we have communication. Korea has a very strong communication sector, but we need to focus more on laser communication. The bandwidth is very big for laser communication, and so basically and right now a lot of companies, a lot of startups are focusing on laser communication, and the forerunners are, first of all, Marriott from France. So when it comes to laser, it goes in a straight line. And sometimes it bends or curves due to air conditions. And Marriott, a French startup, has created a laser communication company to give directions on where to shoot the lasers based on the air conditions. In terms of stylum, because we don't have cluster satellites right now, there's times when satellites don't work that well in LEO. So it's a large-scale communication base to shoot laser communication anywhere to Earth. Now, these ideas haven't yet emerged in Korea. So last but not least, let's go back to Starvest. We provide consulting, and we are an accelerator, and we provide venture capital in defense aerospace industry. I think I'm right on time. If you have any questions, I will take questions from the floor. Thank you. Thank you very much.
너무 말씀을 잘하셔서
Your presentation was wonderful. It felt like a 101 class in modern space industry. Are there any questions from the floor? If you have any questions, please raise your hand.
Thank you very much for your presentation. It was very interesting. So I think you mentioned that you haven't invested yet in a Korean startup. Could I ask why? Okay, to be very honest, to be painfully honest actually, we focus on ingenuity, so innovation, more than profitability. So it's been about 2 years since we've established a Korean brand, and this was something that the former President Moon mentioned and something that the current President Yoon also mentioned frequently. The aerospace policy of Korea has always focused on following other countries in the past, so we took a fast follower strategy. So a lot of great startups that we have in Korea, in our perspective, are not leading the industry. They're rather followers. So that was the reason why. Thank you very much. Does anybody else have questions? Hello. I'm a professor from Yuan University. So going forward for the innovative space sector, I think that you must have made a lot of forecasts about the Korean market. Now we're going to establish a KSSA in Korea. So I'm wondering about what you're thinking about investing in the Korean market. Yes, so we focus and prioritize on innovation when we make investments. So of course, after that comes the scalability, profitability, but innovation is at the front of everything that we look for. I mean, as we all know, Koreans are very smart. Until now, because of our geographical limitations, we were limited a lot. I mean, we didn't even have a lot of space to fly drones in. So if the government deregularizes a lot of these aspects, I mean, create a sandbox, right? Then I feel like we will be able to see more innovations in Korea, right? So deregulation is what you are focusing on. Okay, thank you. We have an investment-related session waiting for you. So I feel like we'll be able to hear a lot of presentations from startups that will change the mind of our presenter here. Please give him another big round of applause.
네,
Next, I'd like to introduce the next session. We have our 5th keynote speech. Let me invite the team leader from Kolon Glotech, Kim Yong-in, The Age of Space Economy, Kolon's Challenges and Tasks. Please welcome him with a big round of applause. Thank you, Mr. Kim Sang-don, for your amazing presentation. It's very hard to follow that. Well, let me introduce myself. I'm Kim Yong-in from Kolon Glotech. This is my first time to present here. I'd like to thank the hosts and organizers and those participating and giving me this chance to present at this Korea Space Forum. When you think about Kolon, sports fashion brand is what comes to mind. Then what can a fashion company do in the field of space? I won't be able to answer all your questions, but I hope this will be some sort of explanation. This is our Magok office, which was built in 2018. If you look at the outer side of our building, we have made the building in the shape of a material that is able to be used in space. Today, I want to talk about the age of space economy, Kolon's challenges and tasks. If you are interested, please feel free to contact us. Let me explain what the Kolon Group is about. As you well know, Kolon Group was created in 1954 based on nylon business. Kolon is a word made up of Korea and nylon. We use synthetic and chemical materials. We also have manufacturing facilities, construction retail business, and healthcare and the bio area are also areas that we are doing business in. We are continuing to discover new industry areas for our future businesses. And I think this is where all our businesses start. We have presence globally. We started our material and global expansion in material in China all the way out to Europe. We are currently manufacturing, marketing, and selling in these markets as well. I want to talk about Kolon Glotech, which is the organization that I am part of. We are a tech and global mobility partner, and we specialize in auto interior materials. When we look at automotive interior materials, there are car seat fabrics, which we are manufacturing. Seat fabric manufacturing is another business that we have. We are also having products in artificial grass. We also have materials that go into car parts. This is for commercial cars, but in the future, we want to have future car, PVB car, and AV materials ready as products. And in November of 2015, we acquired a company that specializes in materials. That company offers military and other special material. I want to talk more about space now. If you look at this slide, this is about what space is. I think you probably have a better idea than me. There's the definition of space and how we divide and categorize space businesses. Recently, the space area has been more private-led. When we first started in the space industry, I studied the space industry, and we thought about what Kolon can contribute to this industry. Korea had Nuri launch, and we also have our lunar modules going into space. We see that not just in Korea, but all around the world, the space industry will grow. And therefore, we thought about how we can make business in the sector. Then why is Kolon going towards the space? Let me answer from a business perspective first. As mentioned, Kolon Glotech is a mobility partner. We work with vehicle, airplane, and defense-related companies. However, when we looked at manned space travel, which will come in the near future, and universal high-tech that is available, as well as higher interest in space through SpaceX and Nuri, we think that we have a space in this area. That is the number one reason why Kolon started to have space business. And I said composite materials, but along with weight lightening solutions for the defense, airplane, and vehicle industry, we have these products and capabilities that we can offer, from commodity to raw materials to parts. And if we look at the capabilities that Kolon has, we can surely use them as a growth driver in the space industry. These are the two key principles that we had in the direction we want to take our space business. This is not just for Kolon Glotech, but it is an important future business for the entire Kolon Group. That's why we need to continue to stay interested and invest in this area. And we don't want to just stop at space business. We want to be able to use this advanced space technology to apply it to the traditional and conventional business areas that we have in our portfolio. However, when we look at the space industry, we are facing some hurdles. In the space industry, heritage is very important, just like the aerospace industry. And we know that that will be a big barrier in order for us to enter the market. Therefore, rather than proprietary technology, we work through partnerships so that we can enter the market and create synergy and create results at the end of the day. We invested in 2 main startups, and I'm going to talk about them in the next few slides. The first one is called InnoSpace. InnoSpace was created in 2017. It is a micro-launch company. They have manufacturing facilities in Kumsan. They also have branches in France and Brazil. They have safety, cost-effectiveness, and speed on their side in their hybrid rockets that uses solid and liquid rockets. Next month, they will have a test in Brazil. If that is successful, it will be the first domestic commercial launch company. Kolon Glotech invested in InnoSpace last year. If I give you a bit more background, earlier I said that our group and Glotech and Composite had very unique capabilities. Combustion tubes, nozzles, pressurization tanks use our special technology. And we are supplying to InnoSpace. We use our proprietary technology in the combustion tubes. As we supply to InnoSpace, we are looking forward to expanding, and we want to incorporate bigger-sized launchers. The next company that we invested in is Nara Space. The space industry was quite attractive, and we ended up investing in companies that have the name space in their name. Both are very strong companies. Nara Space is a micro-satellite manufacturer startup that was established in 2015. As you can see, they manufacture microsatellites and have their own technology. And they are going to launch their satellites in 2023, end of 2023. And the Busan satellite will be launched in 2025. If I give you a bit more background on why we invested on Nara Space, as you could have seen in the InnoSpace investment case, we looked at how we can expand into the space industry as well as how we can create that synergy. I interviewed experts and tried to bring in expert opinion from external, and that's when I found out about Nara Space. Through several meetings with Nara Space, I found that Nara Space has the same direction as us in the satellite industry, and that's how we became partners. Nara Space has bus frame covers, antenna, components, and these components are strengthened and lightened in weight. This is not just for Colon, but Aerospace can use our technology and we can create infrastructure. I talked about Colon Glowtech up till now. Glowtech looks at mobility and composite material, and Colon, each of our affiliates have different perspectives. I think there are 3 different approaches. First of all, we want to be able to use the existing space technology to upgrade our current businesses. Second, we want to find new business areas and promising areas. And based on the current materials that we have, we want to apply new technology. We are looking at the technology and analyzing the list on the TPP put forth by the NASA. There were many limitations in this analysis. When Korean companies bring in knowledge from overseas, there are many difficulties they are facing. That's why we are using this first and second technology to make improvements. First of all, when we look at space clothes, there are many different technologies that are weaved into the spacesuit. So we are taking the fashion capability of Colon, adding on the everyday values that we can add. We go beyond waterproof, heat retention, and go to even self-healing and high functionality special functions. In order to apply this to the hydrogen economy and the future construction area, we will probably work with universities and various research institutions to see which one we want to partner with in the future. Lastly, when we look at the Colon Group's materials and technologies, you could use smart farm technology to go into space, or you can increase the durability of materials that go to the moon or Mars. All right, so that was the presentation on Colon Group and the Colon Glowtech's space plan. Space mobility and composite materials were some of the key ideas in my presentation. We have invested in many startups, and we want to have more external cooperation to create new business opportunities. And based on our individual capabilities in Colon, we want to be able to expand into the space business. We are currently doing business with many different partners with universities and institutions, and we plan on expanding. Even as we speak, Colon Glowtech aims to go into the space future. If you are able to come to the back after this presentation, and after you heard my presentation, I hope you have an idea that we're just not a fashion brand. Thank you, Mr. Kim, for your presentation. You said that you are adding material to the space industry. Are there any questions from the floor? Yes, can we have the microphone over there? Yes, it really seems like Colon is going into the space industry. I'm very happy to hear that. You said Colon has capabilities in composite material. SpaceX, Blue Origin, or other foreign companies, would they know about the heritage that Kolon has? Yes, we are not working with global companies yet. We don't have heritage with them yet. We participated in the ISC in France last September, and I think with these efforts, we will have that global heritage. I believe the Korea Space Forum will provide such opportunities. Are there any other questions? Okay, please, then let's give him a round of applause. Thank you.
네, 이번에
Now we have another special event waiting in store for us. We are going to proceed with the startup investment briefing. First, we have Jo Nam-seok from UEL. He will give us a presentation on unmanned lunar exploration rover. Please give him a big round of applause. Good afternoon, everybody. Nice to meet you all. I am Jo Nam-seok from UEL, Unmanned Exploration Laboratory. So we've been participating in the Korea Space Forum from the very first Space Forum. We still have a long way to go, and I feel like we really have to do better to go to the moon sooner. Because I am presenting in this startup presentation session, I feel like you might think that we're just planning to go to the Mars because every startup is focusing on that. But I want to focus on the profitability of our business idea. So I will explain about the uncrewed lunar exploration rover that we are focusing on developing and also the market for this area. So first, let me introduce our company. We began in 2016 in Busan. And in 2017, we became the family company of Kari. And from 2019, as you see on the slide in the middle, we produce drones and components related to space missions. But then we decided to focus more on rovers. So we were the first to send a rover to Mars in Korea. And I mean, if a rover goes to Mars, then it would need to find soil to plant a lot of vegetables in, right? We were the first to create a rover in Korea to find soil on Mars. So now we are carrying out R&D in terms of rover technology, and now we have moved our base to Seoul. Our headquarters have been moved to Seoul, and we have also a facility in Ansan to create rovers. So we are a startup. So let me briefly explain what we used to produce. We used to create fixed wing aircraft and also legged drones as well as weather forecasting vehicles. And then we decided to focus on rovers. So how could rovers really go out into space and make it to Mars before landing? We also have regolith that has been copied from the actual soil on Moon that Apollo 14 carried back from the Moon. And also we are focusing on AI and autonomous driving technology as well. Through Korea Space Forum, we have made our name as a prominent startup in space industry. So what exactly is moon exploration, lunar exploration? a lot of people see it as a subsector of the space industry. I mean, when we think of satellites, there's a lot of different markets related to it, like satellite components and satellite technology. The same goes for lunar exploration. You can divide the industry, into 9 parts. There's translunar injection, lunar orbit industry, lunar landing, moon base, and surface transit using rovers that we develop, and uncrewed outposts, as well as lunar recovery. So there's a lot of different startups for each of these markets. And instead of just listing all of the startups in the sector, I want to talk about the Artemis mission. That's the mission that everybody is focusing on, right? Other European countries have their own missions, I know, but Artemis mission is the largest mission in that aspect to date. Manned, unmanned rockets, spaceships, space stations, and human landing systems are various technologies that the space industry is focusing on. Right now, everything is led by the public sector, actually. But when we think of moon exploration, lunar exploration, a lot of startups are focusing on this sector. And I think that's because the government wants to leave it up to the private sector once they develop the technologies for man to go to the moon. So there's 4 big sectors here when we think of the Artemis Base Camp. There's the habitable mobility platform, and lunar terrain vehicle, and exploration extravehicular mobility unit, as well as foundation service habitat. And budget allocated for these are about $13 trillion. Trillion won. So every country has allocated budget for space, especially moon exploration, to develop the sector further. We also have Hyundai Motors presenting today, and a lot of big companies, big mobility companies, have proclaimed to go to the moon, as Hyundai has. A tire company has proclaimed that they will send their tire to the moon, and GM, General Motors, has also declared that they will design a moon rover, a lunar rover. Also, Astrolab has designed a rover, a manned rover, to send to space. So automobile companies and secondary vendors are all investing in lunar rover technology. And of course, there's a lot of startups that are researching this area as well and pioneering the area. The same goes for NASA. They have developed their proprietary technology when it comes to moon exploration. I'm sure you all know of the NUDI. It was a public-led effort. And a lot of experts here, sitting here, as well as organizations, joined in the effort to launch the NUDI. So there's a lot of focus on how to make rovers move on lunar soil. iSpace is also a leading company that investigates how rovers can move smoothly on lunar soil. There's also Astrobotic that is leading this area, which uses these panels. And also there's Yaoki, which is an exploration rover from Japan, and it's actually very, very small. It's a minuscule size. It's smaller than the palm of our hands. So we analyzed all of this trend. We can divide these startups and companies into 4 areas. We can divide them into companies that focus on uncrewed exploration, crewed construction, landers, and rovers. So these are all the subsectors that we have inside the lunar exploration market. The sectors you see on the right need a lot of funding, and therefore less startups focus on those areas. And also on the bottom right, you see concept stage due to uncertainty, self-funded long-term strategy. And you could go the other way and focus on low-cost, unmanned rover exploration. So we're developing various rovers. We have 4-wheel SM class rovers and 2-wheel small-scale rovers that we're developing. And also, taking it a step further, we have foldable rovers and also bigger, crewed rovers for construction. We're designing all of these different size rovers right now. So we can divide it into phase 1 and 2 and 3. Phase 1 would be 2-wheel small rovers that would focus on gathering data. And phase 2 and phase 3 would be rovers that can load, that have payloads. How are we planning to expand into the market? So I believe that the government also needs to support us a lot in this sector. So there's a lot of NASA-related projects here. The thing is, the private sector does not actually lead these efforts because these are high costs. But now we see some transformation in the sector. Next, we have space resource extraction, so space, especially lunar mining. And a lot of big conglomerates are involved in this phase. So we extract resources on Moon, and the initial funds, the initial costs are paid by the government, and then the next steps are taken by the private market. So let me introduce our technology heritage. Unfortunately, we do not have a GPS yet on Moon. The regolith on the top 1 to 2 meter surface of the Moon is actually very soft. Now, when rovers try to move on such a soft surface, it's very difficult for the rover to go in a straight line. So our focus is on making sure that the rover can locate itself well and move according to its planned trajectory, and how it can survive the extreme conditions of Moon, as well as what kind of suspension structure is needed to drive the rover well and safely. And also we focus on communication for the rover as well. So we are studying all of these aspects. And on the top you see our man-made test bed that we made. So it's lunar regolith filled environment. We test our rovers here. And as we test our rovers here, we can get a lot of data on how we should shape the wheels of the rovers. And so we have the first rover, which has 2 small wheels, and second rover, which has 4 wheels, and the third rover, which is foldable and very big. So these are the 3 rovers that we are developing right now. Luckily, we were able to exhibit a lot of our products in Washington, Paris, Dubai, representing Korea, because we're the only startup in Korea that produces or focuses on such rovers in Korea. Recently, we found some caves on Jeju Island. We tried to look for caves that had similar environments to the moon, and we saw that some caves in Jeju were fit for our testing. So we tested our rovers in Jeju Island and tested how our rovers could survive on the moon. And domestically, we have a lot of partners. Most representatively, there is KAIST, Hanwha Systems, and Hanyang University, KARI, as well as K-Water. Thank you very much for your attention. Does anybody have any questions? Thank you very much. Yes, we have a question from the floor. I feel like wherever I go, I'm the oldest person in the room. What you said at the very last really caught my eye. I think that we should think of future generations 1,000 years from now. You talked a lot about regolith. Now, I think that we have the potential to go live on the moon if we just create the right environment. We're living on Earth right now because we have existed on this planet for a very long time, and we have the atmosphere that can always shield us from radioactivity. So, going forward, to more efficiently utilize the moon, a lot of people are thinking of creating an underground city, much like the subway stations in Korea. We should take that idea a bit further and create a base on the moon. So I think we should start preparing to create such an underground base on the moon. Do you agree with what I'm saying? Yes, 100%. That's why we actually explore the caves on Jeju Island, to see all of the location data and make that all into 3D imagery. And with our rovers, we're actually conducting a lot of tests, especially with regolith, the man-made regolith that we have. So when Koreans can go to the moon, I do feel like we have a lot of things to research on. Does anybody else have another short question? So we do have some time limitations. We have a separate room in this hotel if you have individual questions. So please ask questions later on and form new partnerships. Thank you very much. Please give him another big round of applause. Thank you.
Next up, I'd like to introduce our next session. We have Kim Young-ok, the CEO of Intelligent Operations, or IOPS, AI Plug-in Downstream Systems. Please welcome him with a big round of applause. Good afternoon, ladies and gentlemen. I'm Kim Young-ok, the CEO of IOPS. I'd like to thank you for inviting me to this amazing event. I'd also like to thank the host and organizers of this Korea Space Forum. The full name of IOPS is Intelligent Operations. We want to provide intelligent solutions on ground stations and in satellites. Today, I want to talk more about AI plug-in downstream systems for satellite constellations. The reason I chose this theme to talk about is because I thought about whether I will have to present to do PR for our company, or do we want to do an IR? I want to make this more of an IR presentation. AI-based technology for downstream solutions is the key of our business, and that's what I'd like to talk about. We are a spin-off company from Kari. I started this company in 2019, January, when I was a researcher at Kari. It's only been 3 or 4 years since we started our company. IOPS has been in business from 2005, and I acquired IOPS in 2019 and added my own technological capability to the company. We built AI plug-in downstream systems for satellite constellations. We want satellites to be operated intelligently, and that is the goal of IOPS. Our vision is to apply AI plug-in technology. Our core value is technological transparency and taking on challenges in regards to the space. I want to talk about the 3 reasons why IOPS is special. We have operated 8 Kari satellites since 2005, and currently 9 are in operation. We run multi-purpose satellites, and we have 3 geostationary orbit satellites. With this operation-based technology, we developed 10 satellite operation software systems. And we are creating ground technology using AI. And we have many engineers who are specialists in AI. The satellite industry continues to expand, and we have low Earth orbits, geostationary orbits, and interplanetary orbits in our satellite portfolio, and we are getting a lot of data from that. We have satellites in low Earth orbit, geostationary orbit, and bottom orbit. And we want to create high value. Since I want to make this an IR presentation, that's how my presentation is formatted. In the new space era, all entities, including clients, want faster and more accessible data. However, in the downstream area, end users still continue to follow. A lot of the times we thought we have this technology, how can we help? We plan on launching numerous satellites, and we have to be able to process information. So how can we do this with AI? As a result, we came up with this solution. Even if satellites increase and even if equipments that go on satellites increase and there's more information, we will use our 15+ years of technology to automate the operation and create value in using imagery as well as solutions that use AI are some of the services that we want to apply to the downstream. We want to talk about service products and business models of IOPS. You can see our services from the left to the right, and we are servicing across the board. In the process of developing satellites, AIT, or assembly integration testing, is one of the things that we do. In Korea, we have orders of the most satellite services, and we are conducting electro tests for 8 satellites. Up till now, we have operated 11 satellites and are accumulating data from those satellites. These are all government satellites. There are 300 billion high technologies involved, so we call this high tech. Once we operate a satellite, we have to receive the data, and we have processing services for that data. And next year, we are planning to release a 4.5 meter antenna system. That system will be able to receive data and transmit it as well as process it. And usage or selling of that data is the next business area we want to go into. And it doesn't end here at sales. We want to be able to make that data more high value. So we will need to be able to process it. And in that process, AI solutions will be needed, and that is what we want to service. We are developing this service. The reason we say we can create these AI solutions for you is because we have multiple different businesses from A to Z. These are our products. There are mainly 2. We have operation software, which we call SatOps. And in the image usage area, we have SatApps. Let's take a look at SatOps first. There are 4 main parts that is important to satellite operations. Real-time operation, mission control subsystem, and mission planning, as well as flight dynamics, are the different parts in SatOps. We already have technology for these 4 areas, and we have in-house systems that are standalone. So we are creating products based on AI. We want to be able to automate and make our systems more efficient. We create products that put OS and AI together, and we want to diversify our portfolio. Now I want to talk about satellite applications. We call it SatApp. Optical or radar or other data are here. So when we put that together, we are able to have a more accurate picture. Now I want to talk about EAD. We analyze the imagery that comes to us, and we are able to detect the changes And by analyzing this data, we will be able to foresee what changes will happen in the future. And we are able to analyze many more different objects. This is our business model. Downstream is our core competency, and assembly, integration, and testing, as well as using the satellite imagery. We want to add AI to this. And you can see on the bottom it says GET. That stands for Global Network. And then experience of 15 years in satellites and technology for AI technology. We want to be able to satisfy clients' needs. We want to be able to customize. And in terms of imagery, we want to be able to provide high-value imagery. It's like making bread out of flour. And clients will be able to use AI solutions to make their evaluations more quickly. And that's where AI is coming in. This is a market analysis, and I'll talk about our financials as well. If we look at the market, we have ground service and imagery usage. Imagery takes up a bigger proportion even in 2021. And even in 2030, I believe imagery will create more revenue. That's why we are focusing on imagery. And even if we look at the regions, the North Americas are very big. In the imagery market, just raw data versus creating a solution out of that data makes a difference. And I brought this flour and bread analogy to explain that. I thought about what kind of flour I wanted to use, but let's say it's 171 for a pound of flour. And then a bread of the same bread would be 5,001. So it's like 30 times difference. And recently in Korea, salt bread is very, very popular. And adding just a bit of salt makes that bread so much more savory. And that's what we want to do as well. We want to have high value added imagery solutions. Many people are already in this business, but they have technology in just a few areas. But we have technology in all downstream areas, so we're very cost effective. We have a lot of experience and know-how. And I believe that makes us competitive. These are our clients. We have public institutions as well as private companies. We have about 100 employees, and we will go to 150 in the year after. We said 10 billion is our goal, but we have already reached 8 billion. So next year we want to go towards 16 billion. 34% of our employees are technological engineers, and we are investing 30% of our returns into R&D. We have our satellite operation division, the system network division, and satellite AI and T division. and then we have our SARE, which is the Satellite and AR research. And this is my profile. I worked at KARI in satellite control and frequency sharing. And I started this company under the name of WaveOn, and now it's IOPS. IOPS is what I acquired in 2020. SpaceX's Starlink needs 3,000 satellites, and we need to secure frequency waves. And so if you want to be in satellite telecommunications, please talk to us, WaveOn, and we will help you secure that wave. Let me talk to you about the board of directors. We have Mr. Choi Jung-yeol, who is our CTO. He has a Master of Physics in KAIST, and he has been a data scientist and AI machine learning specialist for the past 20 years. Chu Han-jung, our CSO, went to school in the UK for his undergrad and grad school, and he is in charge of strategy. Our CFO is Chu Hong-soo, who is in charge of our finances. This is some press releases from this year. We have an agreement for research and development of AI-based satellite data with KAIST. Our catchphrase is from AI to satellites. That means we want to be in the business from AI to satellites. We have AI in downstream. For us to go to satellites, we need a lot more efforts. Our company has 3 things. We do not have any external investment. Also, we do not pay our board of directors. Because I believed rather than paying myself, it is better to invest, and that would bring us more ROI. And now I think it's the right time for us to bring in external investment, and I believe that would enable us to grow even more. Thank you very much.
감사합니다.
Thank you very much. He delivered a very fitting presentation for this session. I hope that the company will continue to flourish going forward. Let me introduce our next presenter. We have Choi Young-in, the CEO of KMASH, and he will give us a presentation on 3D printing-based liquid rocket engine manufacturing. Please give him a big round of applause. Hello, everyone. I'm the CEO of KMASH, Choi Young-in. I'm nervous. It's the first time that I'm standing in front of such a big crowd. Yesterday, President Yoon gave a speech here, right? He declared that on the centenary anniversary of Korea in 2045, we will send people to the moon, to the Mars. And I really couldn't believe what I was listening to. I thought that you might think of me as opportunistic. Maybe some of you might think that I just changed the title yesterday night because Mr. Yoon gave a presentation about sending a person to Mars, but I actually submitted this slide 2 weeks ago, so I want to make it clear. My presentation has nothing to do with what Mr. President presented. Today, I will give my presentation on 3D printing-based liquid rocket engine fabric manufacturing and rocket manufacturing. So I worked in the industry for 20 years, and we started the company last year. So I thought that it was an IR. Next to our office, we have IOPS, and we also have contact in the floor beneath my office. And I feel like this is a very good place for me to be in. And I feel like I should keep being located within Kari to keep using all of its facilities. So my presentation will be like a pitch. I have experience with IR before, and I actually didn't know what an IR was supposed to be about, so I got consulted on what I should include in my slides. So my slides have a lot of words, a lot of wordings rather than pictures. I didn't know that I needed to put a lot of graphics in to grab people's attention. Now we are moving from the old space to the new space. What is the new space? It means that we will start focusing more on economics. So economic feasibility, profitability rather than technology. I saw that on the uniforms of NASA, the phrase failure is not an option. That is the phrase that represents the old space. It means that since a lot of funding is invested in space technology, you can't fail. So it's a very old way to approach this. But SpaceX actually has another phrase on their uniforms. It means failure is an option. In other words, SpaceX wants their employees to fail in order to make something better. And so it's the trend right now to cut a lot of costs. So basically, new space focuses on low-cost, private sector-led space development. So if even one company, one startup in Korea had succeeded in creating a successful launch vehicle engine in Korea, I wouldn't have started this startup because this is such a small market. It's a winner-takes-all market in Korea. But I think that we will see the first launch next year or the year after that. So I feel like we do have a great chance of succeeding in the Korean space market. 500 kilogram satellites take up 80% of the satellite market, and about 10% are 100 kilogram satellites. And the other 10% are even heavier than 500 kilograms. I feel like even if all of this, the Nuri and space launch vehicles are focused by the public sector, the private sector should be able to participate even a little bit. A lot of people in this industry ask me, why did you decide to start your own company? Do you think you have what it takes? But I always say to them that I didn't start this company by myself. I have great partners beside me. About 300 entities participated in creating the Nuri. And now, what sets us apart? We base our manufacturing on 3D printing. On the left, you see 3-ton engine that was made 90% with 3D printing technology. Already, space powers in the Western Hemisphere use 3D painting a lot. We can think of Space Starship, Lepto V2, where 40% of their engines were created with 3D printing already. So already 3D printing is used all around the world. It's not being used right now, especially it wasn't applied for duty, but it has been researched before in Korea as well. So our technology solution focuses on commercialized 3D printing engines. When we try to compete against the US companies in terms of cost, we really can't beat them. That's the hard truth. So what are we doing? I'll tell you about a project they're working on. We're using Telugu 1-stage and also top quality 2-stage and 3-stage engine. If we do this, we can shoot a 500 kilogram satellite up in the space. If we use the KD3 engine, then we believe that we will be able to launch a satellite into space by 2027. So we have named this JEVI-1. Where does this name come from? Jebi is a bird in Korea known for coming back to its home. So for stage one, the first stage, the government really needs to pitch in. So the Ministry of Science and ICT needs to provide us with funding for us to take it to the next level and shoot and launch JEVI-10 to the space. So if we do this, we will cluster 3-ton engines, 10 3-ton engines, and we will be able to shoot 150 kilograms satellite into 500 kilometers of air. So 150 kilogram satellite can be launched at about 2028. So people could say, why did you start your company now and not earlier? SpaceX wasn't developed by Elon Musk himself. NASA and a lot of other national entities pitched in and provided funding. Right now, Korea is starting to focus on new space, R&D. The space sector overall is being centered around private entities. Samsung said that innovation doesn't just come from the ground, it comes from money. If money is invested, we will be able to see innovation in space. I mean, President Yoon said that 1 trillion's worth of budget will go to private entities in space. So I trust him on that. And we also have many Narrow Space Center launch site too, as well as space industrial complex that are being constructed right now. All of these policies will be great support for us, startups like us, to take the next step. We believe that the golden time has dawned. We can't become first movers. It's not easy to attract investment. I think that the best strategy that we can take as a company is the fast follower strategy. So that is the strategy that we are going to take. Launchers in the US are being developed by a lot of prominent startups in the US, and it's being produced using copper right now. It has gone through significant testing. So let's look at the market potential. I took this from the newspaper. In 2020, the entire market is around 550 trillion. It's not a small market, actually. Now, when we look at the domestic scale, it's around 4 trillion. And launch vehicles take up 0.37 trillion won, which means that it's less than 10% of the entire space market in Korea. Now, we should think about prospects. As of 2024, Morgan Stanley said that it would be about 1,100 trillion won's worth. And another prominent company expected that the market will be 3 times of that size. I predict somewhere in between. And I also have my predictions about the satellite market. When it comes to small-scale launch vehicles, I'm sure you know this, but Hyundai last year declared that they will start developing small launch vehicles, and they have their first plan to develop a reusable small launch vehicle within the next 10 years. So I looked at articles from Hyundai. They predicted that the small launch vehicle market will be about 9 trillion won's worth in 2025. So when we make investments, our scale is around 30 billion Korean won. So there's a lot of startups like Peerage that have successfully finished their investment rounds. What sets us apart? We really haven't attracted a lot of investment yet. Well, the thing is, we are developing kerosene engines. We have moved on to stage combustion engines early on. About 30% has been already developed. You might think, is K-Mash's engine competitive? And I want to stress that it is. I mean, Hanwha Aerospace is developing their own engines, and they are a big company. ISP means the efficiency of fuel in a rocket, so the mileage or fuel efficiency in a car. And the graph below shows that we have good fuel efficiency. We have different companies here listed, like Perigi, K-Mash Innospace, and Hanwha Aerospace. And with this graph, you can see that we actually have the best speed and the best fuel efficiency in terms of small launch vehicle engine. So the business model. We want to procure orders from the government and private sector R&D, and also get orders on domestic satellites to overcome prominent companies like SpaceX. So our base is in Korea. For the last 7 years, we were involved in engines, especially 7-ton and 10-ton engines. I've always conversed with Hanwha when it comes to manufacturing engines. And in 2019, for about a year, we went to the preliminary design stage of 3-ton liquid rocket engines. Right now, there is the Ukrainian war, and we are working with a company named Fight Propulsion on working these engines. So there's a term, MVP. We are currently in collaboration with that company, and with flight control propulsion, and we have created viable products already. I'm talking about minimum viable products, and I have the products that we developed in my bag actually already. So let's talk about our plans for the future. Right now, there's a new term, EVA. Before, we only had MVP, minimal viable product. Now there's a new term, essential value achieved, EVA, which takes the risk out of these projects. Now, the most difficult aspect of completing the NATO project was getting Russia's EL. So we're considering the acquisition of EL from this stage. And in 2024, we will finish the critical design review of the 3-ton engines. In 2025, we will test the power pack of 3-ton engines. And I already have the certificates, the licenses for engineering these power packs. In 2026, we will begin with the combustion test of 3-ton engine. Just like Nuri did. In 2028, we will be able to assemble and test launch JV-10. This is our big dream, our big vision. And this ends my presentation. Thank you very much. Thank you very much, Mr. Chae Young-in, for your presentation. It was very catchy and fun to listen to.
마지막 연사분을
Now I'd like to invite our last venture. Mr. Park Jae-hong will be talking about Unastella Corporation, the brightest star. Please welcome him to the stage. Good afternoon. Hello, I'm Park Jae-hong, the CEO of Unastella. I am bringing a very difficult product, so I'm bothering a lot of people around me with it. Let me talk to you about what Unastella is. I think the slides are different. It's not the slides that I brought, so I'm sorry about that. I'll be talking about Unastella, and then we're going to be talking about what our company is about. So we're supposed to have music, and it has very beautiful music in our slides. Sorry, I'm not able to show you that. Low, mid to high orbit is where we aim to go. We build up platforms for human spaceflight. I want to talk about why we want to go to space. We need to start talking about new space, but I think a lot of people already covered that. New space is a private-led movement rather than government-led. And we believe that there needs to be more flavor to that movement. The government, due to ideological, security, defense reasons, now the private is taking charge, and the private sector is going to play the role of a catalyst. And I believe that new space is all about governments helping that effort. At the end of the day, we want to send people to the outer space. How are we going to make this unbelievable dream possible? There are critical subsystems in a rocket. There's unmanned and manned rockets that require these common components. We want to use integrated designs in subsystems for rockets and for fire-spitting combustion chambers. We have testing in progress, and we have tested tanks, and we are testing them so that they can be certified from a government level. And we are planning to have our first technological demonstration. We do not use tower pump cycles. We use electro-machine cycles. And we have contracts for knowledge transfer with the company that has the highest capability. And we're going to be able to bring that heritage, to bring a final model to the markets. It looks like a very aggressive plan. You ask, can we do it? And we want to say, with our experience, it is possible. When we look at the rockets, We take into account people and have created this. And we also have interpretation platforms that can be used. And this is the cycle which is the key to engines. The Germany Space Center and also many institutions have helped me to decide on the final design. This combustion engine has already been designed and created. We have this demonstration model that has been completed and assembled and certified in September. We will be launching this soon. Sorry, this doesn't even show the results of our tests, but I want to say that our designs are completed. Our testing has been completed. Yep, so this is the fire star because it shoots fire, and I think later we will call it shooting star as it is flying into space. And we have our own facilities here. And we have many different manufacturing methods that we are using. And we are creating this algorithm for ourselves. We are working with Berlin Engineering School, who has much experience in launching satellites. And the satellites that they plan to launch will be launched by our company, and so we have a common understanding. Our electric pumps are from knowledge transfer from the best companies and institutions in Korea and abroad. We have done a lot in the past 9 months, and I believe we can complete this whole plan within 2023. And our aggressive plan to launch our products seems possible. We were established in February, and we received our investment in March, as well as qualified for TIPS. And we have survived so far. And we are working on the next round of investments. I think one representative milestone is the engine combustion performance. And with 2 attempts, we were able to get 1 successful case. So that is our plan. So based on this plan, we want to send man into space. And based on the revenue we bring in, we want to be able to send someone into space. It seems unbelievable, but that is our dream. If I try to summarize our milestones, when is the point in time we can bring in money? And we want to go public. However, electric motors, which are very attractive products, I think can hit the market and bring in money even before that. So these satellites and even people will be able to do space journey, and I hope that we can send a man on Moon or Mars in the future. So based on this business model, where does our revenue come from? It would be the satellite launch service. We're thinking 30 million won per kilogram as a price. And this is strong fundamentals which will allow us to bring in revenue. We also want to be able to purchase engines to create revenue. And at the end of the day, we want to create human space flight. And I believe this is one of our key merits. But the pumps that we make can be used in other industries, so our business can be pivoted. If I show you the upside, it's as follows. We want to go over 100 billion by 2028. People ask us, can you do it? And we don't know yet, but I want to introduce my team members. There are a lot of engineers on board that were from DLR, as myself, and there are many specialists in aerospace and electricity. And I believe this really shows you how powerful our team is. And I showed you the design, so this is a summary of the whole design. And this is our philosophy in terms of design. What we want to do, what we need to do, and what's nice to do are the three things that we really differentiate. We want to go very fast, and if it's something that is not totally needed, we want to go as fast as possible and focus on the things that we need to do. This is the list of our UNA supporters. This is a very strong network that we have. Astra sent a rocket into space faster than SpaceX. And our dream is to do better and go faster. We want to use our capability, network, and infrastructure to be the best rocket company in Asia. Thank you. Thank you, Mr. Park, for that presentation. It is amazing to hear that it has only been 9 months since you have been in business. Let's end the session here. Let's have a quick break. We will have a 20-minute break. Let's come back at 4:10. Thank you very much.
I hope you had a nice rest. Let us proceed with the forum. For all of you out there in the hallway, please enter the conference hall. So we have a special session. And before we go into the session, we will proceed with the 6th keynote speech. We have Masayasu Ishida, the CEO of SpaceTide. He is here with us in person. He will be talking about space industry, bringing new values to the society, life, culture, and future. Please welcome him with a big round of applause.
Well, thank you for the kind introduction. So, good afternoon, everyone. My name is Masa Ishida, CEO of SpaceTide Foundation. So, I'm so excited to be here because this is my first in-person participation in Korea Space Forum. So, thank you, organizer, for providing me with the opportunity to be part of this excellent event today. So, first, let me briefly introduce myself. So, I incorporated the SpaceTide Foundation in 2015, so with aim of driving the future of human society through the space industry. So SpaceTide is a Tokyo-based non-profit organization. We cooperate with a wide range of organizations, individuals, and perform various cross-industry activities. In addition, I also leading Kani's Global Space Group and providing management consulting services to a wide range of clients, from the government agency to space startup in global. On top of that, I have contributed to the policy making in the Japanese government as an acting member of Japan's National Space Policy Committees. So as we discussed today, our global space industry is undergoing a major transformation. So various factors such as or increase in the number of space nations, expansion of private space business, diversification of space application, and also a rising sense of crisis about space sustainability have come into play at the same time. So it's clear we are entering the new era of the global space industry. And moreover, as the space industry matures, this industry is now creating new value for the world and society. So in my speech, I'd like to introduce my views on the value created by the space industry. So please look at this chart. You know, human civilization has spread over land, sea, airs. Our lives has become richer. Global GDP has grown, but causing serious climate crisis, ecosystem destructions. I would say humanity may erode the planetary boundary in the near future. Sustainable Development Goals established United Nations are universal language and common challenges facing humanity. But at the same time, for the sustainable growth of our civilization, we need the next frontiers. So where will humanity's next frontier be in these times? I would say space and the virtual world are considered as the last frontiers that will not further burden Earth. You know, space activities has been accelerating. Over the past decade, number of launch has doubled, resulting in 5 times as many satellites, twice as many people who have gone to space. Space activities has also been diversifying rapidly as well. Current space industry can be categorized into 6 segments: satellite application, satellite operation, in-orbit servicing, launch service, space tourism, and space exploration. Space industry encompasses more than just the traditional space nations. Nations around the world are fostering and joining the new space movement, influenced by different factors with entirely different goals from country to country. Over the past 10 years alone, more than 25 countries and regions have established their own national space agency. And you know, investment in the space industry has also been accelerating. Many industries were affected negatively due to COVID-19 in 2020 and 2021. But the investment in the space industry has continued to grow strongly. As such, our space industry has accelerated toward its commercialization and is expected to grow at a high rate. Moreover, as the space industry matures, this industry is now creating the new value for the world and the society. Here's a question for all of you. What will the space industry bring to a society, life, culture, and the future? So I'd like to think about it together with all of you. Historically, you know, space activities have contributed to our security and science. Even nowadays, our space industry is becoming increasingly more important for security and defense. Moon Earth Mars exploration generating a lot of attention from various countries. To capitalize on emerging these trends, nations around the world have been accelerating their national space program. However, is the space industry showing its full potential? I don't think so. Please look at this chart. Compared to the space industry, ICT industry is about 10 times larger. Automobile industry is about 15 times larger. And healthcare industry is more than 20 times larger. These industries support our social life with the latest service and technologies under the soil in which the private company thrives, creating new jobs, spawning a variety of technological innovation. space industry is still considered to be a niche industry when compared with the other major industry. So I believe space industry can and should contribute more to the future of human society. In order for the space industry to create new barriers, so there are 4 approaches. So I'd like to deep dive into each approach. And the first approach is to utilize space to solve socioeconomic challenges facing civilization. You know, space system has already served as a critical infrastructure in our daily lives. Observation satellites enable weather forecasting. Communication satellites are utilized for backhaul for mobile network, and also in-flight connectivity. If the satellite system were to fail, socioeconomic loss could amount several trillion US dollars globally. Considering this fact, I would say satellite systems are critical infrastructure for modern life. However, looking back at Earth, we can see many academic, social, and economic challenges facing humanity. We have been facing the COVID-19 pandemic over the past 3 years. Not only COVID-19, there are many other challenges facing humanity, such as climate change and poverty. There are also various economic and industrial issues. I believe space industry can help solve these challenges facing humanity. Especially, satellite technology can contribute to solving all 17 challenges of SDGs. You know, historically, satellite communication has been niche technology, mainly used by the government and limited number of industries. However, emerging players are deploying the large-scale broadband constellation to provide high-speed, low-latency internet service from space. Satellite communication is expected to transform the internet access around the globe and bridge the digital divide globally. Traditional use of positioning satellite or location data, such as map application and/or car navigations. However, because of a higher precision location data, new use cases are emerging with autonomous driving, drone, sharing economy, and also a wearable device. More accurate they are, the higher value these modern technologies will bring to our societies. Second approach for new value creation is to explore space to sustain dynamic growth and changeable civilization. You know, the year of 2021 was the birth year of our commercial human spaceflight. SpaceX succeeded all civilian human spaceflight missions to orbit. Several civilians, including Jeff Bezos and Richard Branson, reached the edge of space. I would say we can see a new era of commercial human spaceflight. Suborbital spaceflight is expected to grow in the near future. There are also numerous plans for commercial space station. People will go to more distant places, such as Moon and Mars. For example, a Japanese billionaire, Yusaku Maezawa, is planning to ride a Starship travel around the Moon in the near future. I believe more and more people will go to space. However, here's a question for all of you. Why do we explore space? Is it for entertainment? Or is it for science? Is it for national presence? I'd say we explore space to save the blue planet. Looking back at Earth, humanity's energy consumption has continued to increase more than 2% over the past 50 years. So humanity may erode the planetary boundary in the near future. As you know, Elon Musk, SpaceX, plan to send humans to Mars and build an outpost as a backup drive of our civilization. In Japan, where I live, the concept of Planet 6.0 was proposed by an academic industry group as a vision for future of civilizations. This envisioned the Earth and the Moon integrated as one ecosystem with a cyclic or social economy. Becoming a spacefaring civilization may be a way to save the blue planet. And the third approach for the new Barr creation is to create space to develop and expand our new civilization. Geospatial or satellite imagery has been utilized for various sectors, and geospatial analysis can help visualize and solve many socioeconomic challenges facing humanity. So many companies are providing actionable intelligence by combining the satellite imagery with advanced statistics and industry expertise. But our new challenge has begun in Japan. A high-definition metaverse is being created by melding satellite imagery with other cutting technologies. A company called Space Data is developing an algorithm to automatically generate another Earth in the virtual space by using our 3D CZ technology and also enabling the AI to understand the geospatial information of the Earth. Various economic activities such as consumption or entertainment and work will be taking place in multiverse space in the future. Reports say the size of the metaverse market will reach 1,500 billion US dollar by 2040. It's much larger than the size of the space industry. And the fourth approach is an enabler that support other three value creation opportunities. Is to evolve space ecosystem for continuous benefit to a civilization. You know, historically, humanity has always run into a problem when exploring space. So think of age of discovery, 15th centuries. And also a gold rush in 19th century. There are always conflict of interest, dispute, and also ecosystem destructions. Indeed, space faces a variety of challenges. Various factors are coming into play at the same time. I believe it's important to build a common understanding on the current state of affairs, build a larger ecosystem to achieve the progress for the industry as a whole. We SpaceTide would like to propose actions required to evolve space ecosystem. First is to position space as an enabler to solve socioeconomic challenges, as I have been saying. Second is to foster self-sustaining industry in an era of innovative public-private partnership. And third is to accelerate the collaboration across the country, across the industry and the sectors to materialize the potential of the space industry. And the fourth is to complement each other's capabilities, the value chain across the country and the region to grow this industry as a whole. And the final one is to build an international framework and incentivize our behavior. With an increasing number of stakeholders it's become more difficult to build an international framework, but it will be extremely important for the sustainable growth of the space industry. From this point, so let me talk about the APAC space industry. You know, APAC space industry is characterized by a rich diversity of countries with a significantly different social system, or historical background, national space capability, and also industrial ecosystem. Space industry or space activities have been carried out in a limited number of countries, but recently space activities are accelerating across the APAC region. We estimate 120 rockets was launched this year worldwide, and 54 of them was launched from Asia-Oceania region. 18 countries and regions have their own national space agency. In addition, number of space startups is increasing. We estimate more than 300 space startups are engaged in a wide range of space business. I would say APAC will reach the next growth phase of the global space industry. To encourage the space activities in the private sectors, government in each country have been implementing a variety of measures to support the private space activities. I think role of the government should evolve. You know, traditional approach is to create government-owned space system working in a government contractor relationship with the industry. However, government is now implementing a different approach where government serves as customers, investors, and also partner of the private space companies. With the increasing number of stakeholders, we can see a sign of a new industrial ecosystem development in the APAC region. Traditional ecosystem for government-led space development looks like a pyramid structure with a space agency at the top. On the other hand, industry ecosystem for commercial space is becoming more diverse and international, so with a number of stakeholders increasing as well. So this wide variety of stakeholders should have to act harmoniously each other to achieve the progress for the industry as a whole. We SpaceTide would like to play an international role by being a venue for such cooperation, partnership, and harmonization in the APAC region. Our vision is to drive the future of human society through the space industry. Taking a neutral position, we cooperate with a wide range of organizations and individuals and performs various cross-industry activities, such as organizing the conference, publishing our space industrial report, and also providing our mentorship program to our space entrepreneurs. One of our main activities is organizing one of the largest space business conferences in the APAC region since 2015. So this year's conference, SpaceTide 2022, was held in Tokyo in July. It was attended by 80 speakers from 20 countries and also 700 participants. So we bring together our global space leaders under one roof to discuss the forefront of our commercial space activities. We have been also collaborating with the Asia Pacific Regional Space Agency Forum we call the APR-SAF. So APR-SAF has been our largest space community led by the Japanese government and mainly attended by the government agency from the APAC countries. So together with JAXA, National Space Agency, So we have been co-hosting the first industry forecast initiative of the APR staff. So this year's our space industry workshop was held in Vietnam this month, 2 weeks ago. So it was attended by 150 people from 20 countries. So we had a various discussion about public-private partnership in the APAC region and also commercial space policies. We also published our own space industry report called Compass to provide a bird's-eye view of the industry landscape, containing a players map or investment trend and also investor profiles. Compass analyzes the progress of our entire commercial space activities. As my individual activities, I've contributed to the policy making in the Japanese government as a member of Japan's National Space Policy Committee. You know, Japan has seen 50 years of space development led by a National Space Agency, JAXA, but our interest in commercial space has increasing in both the public and the private sectors. Now, government sees space as an area of future growth and have been implementing a variety of measures to support the space activities in the private sectors. As a result, there are more than 80 space startups engaged in a wide range of space business, including some of the famous space startups such as Axel Space, iSpace, and also Astroscale. In addition, large corporations from various sectors such as automotive industries, airline industries, trading industries, electronics manufacturers, machinery manufacturers have begun to invest in the space industry. This wide variety of stakeholders participate in the space industry has not seen in any other countries, so I think it's a characteristic feature of Japan's space ecosystem. So I'd like to wrap up my talk. So as I have been saying, space industry is full of many possibilities, and this industry will bring new barriers to a society, life, culture, and future. However, to materialize the potential of the space industry, we need to evolve space ecosystem. So it's important to build a larger ecosystem across countries and industrial sectors. So I hope the space industry will expand its horizon and market size. There will be many winners. So I expect the space industry will become a greater industry in the future. Thank you for paying attention.
Thank you very much, Ishida-san. It has been a very inspiring message. Throughout the message, I've been asking a lot of whys and hows instead of what. 네, 오늘 정말 좋은.
Thank you for that wonderful presentation. Do we have any questions? All right, then let's end the session today. Thank you. Please give him a round of applause.
Here.
We have another special session in store for all of you. Now let us introduce the chair and 3 speakers. First, we will welcome VP Lee Jun-hee from Boryong Corp, as well as Senior Manager Kim Se-hun from Hyundai Motors, and CEO of Aerospace Satellite Solution of Song Min-jun. And we like to also introduce the chair. So we will introduce 4 panelists. Please give them a big round of applause.
네, 안녕하세요.
Hello, I'm the chair or the moderator, An Young-jun from Kari. Nice to meet you all. We will proceed with our masks off. So we've had great sessions yesterday and today. This session is going to be a little bit different. We're going to have our panelists here with us all together, and I'm going to be moderating, so we're going to have a more casual talk. So we are SPLEC, and this is a special session to talk about expansion of the space industry. So this is the 4th Korea Space Forum. We participated, the Space Policy Research Center participated in the very first Korea Space Policy, and it's great to see that we are having our 4th Korea Space Forum. And Mr. Ishida-jang, who just gave the last presentation, has participated in this forum virtually from the very first forum, and he gave us a very important insight about our culture, about our economy, about our society, about ecosystem. And I think our talk right now continues on what he wanted to talk about. Non-space actors, so non-space startups, could give presentations in the Korea Space Forum is what I thought for a very long time, since the very first Korea Space Forum. So I always wish to see companies in non-space sectors participating in this forum. And this is the first forum that we've made that come to life. So we have representatives from pharmaceutical companies, as well as an automobile company, Hyundai Motors, as well as a spin-off startup in maritime. So the space industry needs to develop into a scalable and web-like industry. For that, I feel like we should talk about the challenges facing these various sectors. So the 3 speakers that we have will give their presentations. First, we will have a presentation by Lee Jun-hee with the topic Care in Space, Leading Space Medicine. Hello, as introduced, I am from Boryong. I am Lee Jun-hee. I am the VP. First of all, I'd like to say that I am honored to participate in the Korea Space Forum, which is leading the space industry. And also, more than anything, we are in our initial nascent stages in Boryong when it comes to space. So I'd like to thank you all for inviting me, all of our frontiers and distinguished guests in the space sector, for inviting our nascent company. And it's great to be sitting down for this talk as well. I think you'll be able to see my slide here on the screen. We have the logo, as you can see, Care in Space. From 2020, we started to take interest in space. And from the beginning of this year, we decided to aggressively act on our thoughts and explore space. We are going to step into the space age, the space era going forward. We will face many challenges along the way, and space will be a new opportunity when it comes to commercializing various aspects. So we thought it was appropriate for us to find those new ideas and commercialize it, bring new values into life. That's why we created this logo, and we are currently endeavoring with the logo in our mind always. So today, my presentation will be in the following order. First, I will explain Boryong, We are a pharmaceutical company. Many of you might think, why is Poryong venturing out into the space market? A lot of people asked us that question when we first proclaimed that we would be taking an interest in the space sector. A lot of people were curious to find out about our intentions, so I'd like to explain the backstory of how we decided to venture out into this market. And second, the first CIS Challenge Accelerating Program is being proceeded right now, and we are involved in it. So I'd like to explain about what that first CIS Challenge is. A lot of presenters went before me, and most presented about aerospace technology. I'm going to be straying a bit further from technology and talking about how a non-space actor can approach the space field. So here you see 3 articles on the screen. The one at the very top states that Poryong will create new medicine in space, and that Poryong made a pre-investment to XCM Space of $10 million. So we gathered many startups and companies to join us in our endeavors. And right now, after we went through a process of selection, we chose 6 final startups for the first CIS challenge, which is shown in the article on the bottom left. A lot of people showed interest in the first CIS challenge. We were very grateful, and we also felt a heavy sense of responsibility. This is a photo taken way back in the day. So the picture you see here is a picture of Ballroom pharmaceutical store in Jongno. And Yonggaksan Gelpus is the medicine they made us establish our grounds in the 1960s. Right now, we have about 750 billion won, and in total, about 1 trillion won's worth of revenue. So we are a well-established, middle-sized company. The reason why I'm showing you this picture is because back in the day when our company was founded, so in the late 50s, it was very difficult to find even antibiotics. So the founder of Poryong, when he was very sick, had to ride a bicycle out to the town and spend the whole day getting medicine. So because he knew how critical medicine was, he decided to establish the company Poryong. In the beginning of this year, we changed our company name to Poryong. That's because, so we took out the pharmaceutical part, and that's because we wanted to say that we are willing to go beyond the pharmaceutical sector. So we took many business strategies. Of course, we will continue to grow our pharmaceutical sector, but we wanted to find a project, a business that would make us create long-term value for our customers and clients. Now, all of that began with one question. When we send people to space, we send the healthiest people to space as astronauts. They pass various tests, physical tests, to be selected as astronauts. So then, can sick people or just ordinary people go out into the space and explore space? We say that we are venturing out into the era of space. So can ordinary people, sick people, also stand with us along that journey? Experts said that not a lot of companies are focusing on this aspect of space exploration. And that was when we decided that we should focus on care in space, sending sick people into space. It took quite some time to make our ideas into reality, but we started forming our idea and forming the team in 2020, and this year we were able to disclose our project openly. So on the picture, on the slide, you see the CEO of our company. We actually don't have a lot of accumulated technology in terms of space, and that's why we wanted to partner up with big companies who had great technology on space. So we promoted our project as well as we could, every chance that we got. This is the first picture of the Artemis 1. In 2020, when we started envisioning care in space, internally and externally, people were asking questions about when the age of space exploration would really take off. Now, if you research on ideas you want to know, you will get the answers. So, as we are more involved in this area and as a lot of people are focusing on this area these days, we now see that the space of age is dawning upon us. On Artemis, a mannequin was used. But going forward, we believe that in the near future, people will be able to freely explore the world. We believe that there's a lot of commercial opportunities here. This is a photo of an event that you all know, I'm sure. It's a photo of the Duri, which was launched last June. We were all touched watching this national event. And also, yesterday we heard President Yoon say that KASA will be established. So we believe that if we continue to try our best, we will be able to realize our dreams. Now let me talk about the challenge, the Care in Space Challenge. The Care in Space Challenge is the first of its kind, leveraging the extreme conditions of space to not only drive innovation, but also to build viable businesses at the intersection of commercial space and biomedical space. Every year, a collaborative effort between Boryong as well as various other startups and companies are ongoing.
This is from the Axiom AX1 from April. Many companies are already preparing for space journey. And in the low orbit, we have topics such as stem cells, AI, and other biotechnology-related topics. The challenge was hosted by Boryong and powered by Axiom Space, as well as a startup accelerator who also presented today, Starburst. We worked with many different universities and experts. 40 teams participated, and we supported 40 of them. And we selected 16 teams who were able to present their idea in Los Angeles to pitch their idea. There were 3 phases in the challenge. In the spring, people submitted their ideas. In the summer, we selected them. And we also have support for these people to realize their business. 6 teams were selected, and as a result, these 16 teams presented in front of 200 experts and industry and people in the industry at the California science industry. And we plan to have this aired through our channels. Rather than talking more, I want to show you interviews from our last challenge in August. It is about 1 minute and 30 seconds.
Nelson said, rockets runs on fuel, NASA runs on inspiration. That inspiration will lead more and more people to space. That's why we're here. We need to be ready to send people to space safely. That's what all carrying space is all about.
People are starting to think about how do we live in space and how does humanity thrives in space. So bringing all of that together and figuring all of that in terms of bioscience, life science, health science, all of that I think is incredible.
We're interested in not just this first year, but also how you evolve and how the program takes on more participants, more companies, more things that get flown, more things that help humans on Earth.
I want to see how they show their passion in their field. I want to see that, and then I can bring their passion into my research. And probably you can do collaboration in the future.
One of our initial projects were developing extended reality applications to train astronauts in how to take care of emergencies in space. So that's what inspired us to go into extended reality. So it makes a lot of sense for us to be here and try to pitch our idea in how to deal with the challenge of health in space.
Yeah, I expect a lot of helpful connections and hopefully some really good advice to help us launch our next stage in our platform.
This is only the beginning, and I'm already excited about what we're about to experience with all of you here. And with the support, I can guarantee that it will be more than exciting than the first one.
The 6 awardee companies that were selected was the interview that you just saw. We had Deep Space, which is an AI-based space research biology company. Xtory gives psychological stability through XR-based enhancement. And these are the teams that had great ideas. Boryong invested the first investment, and they will be meeting more investors in our next event. For the awarded teams, we are giving them seed money as well as programs and giving them the chance to attract more investment. We are having this event with experts in the field so that these people can take the lead in order to grow their business and make their ideas marketable. Also, I want to introduce one more thing. This is Axiom Space's AX station, which could be an alternative to ISS. There were many different tests and experiments in low orbit, And we are preparing for partnerships with other companies that can help us do this. Lastly, we want to talk about the vision in relation to CIS initiative. We want to discover companies that can contribute to biomedicine in space. And we want to create an infrastructure for space biotech. We're just starting now, but I believe that this pioneering area has a lot of opportunity and has a lot of promise for the future. We hope for your support and interest in the future. Ballroom is not a company that has researched in the field of space for a long time. Through our 1-year experience, we felt that there is a plethora of expertise, and we believe working with experts is the key. I hope that we can communicate and work with many experts, institutions, universities, etc. And we want to run the program in a more expanded way next year. I hope and ask for your interest and support for our next challenge and give us a lot of ideas. Thank you very much for inviting me to this honorable event. The answer lies in far space. I truly can feel the passion and the spirit of taking on challenges of everybody who is present today. I hope that we can take this energy to create fruitful results. Thank you very much for listening. Thank you, Mr. Lee, for your presentation. It was in the presentation as well, but Kim Jong-gyun, the CEO of Ballroom, has been participating in our forum from the second forum. And before they started their study, they reached out to us for a lot of advice. And I hope that someday Ballroom can present, I hope that they could present what they are working on, and it is my honor to be listening to the projects that are continuing in Ballroom. I have a question before we move on. We look at a lot of case studies from abroad when we are doing things like this, but it is very interesting that a Korean company is doing this. So I feel very proud. And it looks great and all. But we have to think of it from a profitability standpoint as a company. How do you make the money? It looks great and is inspiring. And Ballroom is a very famous pharmaceutical. So in the pharma industry, or even within your company, is there a difference of opinion in terms of space business? And how are you convincing them and continuing this project? Right, I think you are asking about the fact that companies need to be profitable through their investments in the long term, and in the midterm, there has to be results. A lot of people sometimes criticize us on this is useless, etc. And even within our company, because this requires money and investment, our board of directors, getting them on board was very difficult. So the CEO's intent and willpower is the most important factor here in conducting this program. And rather than short-term results, and the Korea Space Forum is also a great venue. Korea needs to have more interest in space business, and as we do that, we are getting a lot of support as well. So I think with that willpower and passion, I think we can garner more attention and interest. 40 companies submitted their ideas to the challenge, but unfortunately there weren't any Korean companies. So I'm hoping that in the future, universities and institutions will find out about our challenge. So I think we need to do a bit more PR. There were a lot of companies that really struck me today. And I hope that startups and many research facilities in Korea can join our challenge so that we can create a more meaningful one. Thank you very much. Space healthcare, space biomedicine is still a very high-tech and sophisticated area that not many know about in Korea or overseas. And we look forward to how that progresses in the future. We'll get questions from the floor later, and let's move on to Hyundai Cars, Automotives. Mr. Kim Se-eun from Hyundai Motors will be presenting. Please welcome him with a round of applause.
예, 안녕하세요.
Hello, everyone. Like introduced, I am Kim Se-hoon from Hyundai Motors. I heard a lot of the startup pitches because I came here earlier. I will introduce our company, but I think we are all on the same boat, to be honest. Just like Boryong, we have been studying this field for about 2 to 3 years. We have a team designated to this area that we just recently formed. And the more we know about the space sector, the more difficult it is for us to succeed. It seems like about 80 to 90% focus on this in the space industry when I go to various space events feels like it's on the launch vehicles and satellites, and it seems like there's already been great achievements. So we feel like we have a lot of things to learn already. I will be explaining sectors like mobility and robotics. And in my perspective, dare I say it, it seems like we kind of ventured out into a nascent territory when it comes to space. I'm talking about mobility and robotics. It's not an easy challenge, but it is a challenge worth taking on. So I will explain why Hyundai Motors is interested in these projects. We didn't create this image that you see here on purpose. We actually made that for CES recently. I feel like we're all heading towards the same goal, so let me introduce our company. History. The reason why I say that we're all on the same page is because when we look at our history, you can really understand why Hyundai Motors Group decided to walk this path recently. We began in 1946, and we were a construction company back then. And when you look inside of this arrow, you see that in important moments of Korean history. So I'm talking about some milestones that many people questioned at first. Hyundai Motors always participated in creating these milestones. For instance, there's the Gyeongbu Expressway. Many people doubted whether this would be profitable or successful. And there was the Soyang River Dam and also the Kori nuclear plant, which is the first nuclear plant in Korea. And so basically, all of these milestones that you see inside the arrow show the achievements that made us who we are. We also created the first hydroelectric vehicle production car in the world. On the right, you see our own original EGMP platform, which is an EV dedicated platform. When we created the EGMP, not a lot of companies had their dedicated EV platforms. When we created this, a lot of Japanese companies were thinking of using both hydrogen and electricity for car batteries, and so basically through this, I want to mention that we always try to revolutionize the market. Even if things didn't seem profitable, We believed in the potential of the projects that we took on, and that's shown in our history, our company's history. Now, this information is information that you can find anywhere else. It's an overview of Hyundai Motors. We put it in here because we do have a lot of R&D expenses. And unlike what many people would think, we actually don't have a lot of operating profit, but we still invest heavily in R&D. Right now, we're investing in EV, smart mobility solutions based on hydrogen energy, and also robotics, meta mobility. In the area of automobiles, the biggest challenge that we are taking on right now is similar to the problems that have been mentioned. As human society evolves, we are facing inevitable problems. Every city is facing pollution issues as urbanization speeds up. This leads to more population and less infrastructure and worse traffic jams all around the world. Also, of course, I'm sure you know that there's a lot of new environmental regulations, so we have to respond to that. Cars that used to run on internal combustion engines have now become electrified, which leads to a convergence of industries that we did not think of in the past, which leads to the fourth industrial revolution and the advancement of ICT and a lot of products commercializing. So it's our concern whether the technologies that we are currently studying will be enough to solve all of these problems. We don't have the answer for now, but we will keep on taking on challenges. So mobility. The future direction that Hyundai Motors will take will stray away from simply manufacturing product and selling product. So the keyword that can be described is mobility. We're not just going to be selling products. We will be supporting people moving from one place to elsewhere. In the process, services and products can be sold all together, and there could be also additional value created. That's why our keyword that we set is mobility. How can we prepare for the era of mobility? We announced our mobility strategy.
So if I give you an explanation, you can see in the middle it's Smart Mobility Solution Provider. We have 3 pillars that constitute this. First is Smart Mobility Services. And you can see on the right hand corner, there is eco-friendly energy and ecosystem solutions. I'm not declaring that we're going to do all of these. I'm saying that we need them. And I believe there are experts and companies that are specialists in these fields. And I believe that we need a partnership and a convergence in these areas. Our strategy is in smart mobility provider. And so these are the pillars that make up that strategy. And so we want to be able to provide that mobility service that can take in all of these pillars. I know we're talking about space and I'm talking too much about cars, but I believe it is closely connected to space. When we look at robotics, you can see them in animations or in movies. It looks like robots are very cool and they can fight. That is robotics, but from a mobility perspective, the movement that they make, how do we bring that into our current lifestyle? would be the main question. And I think people are quite similar. I think NASA has a similar concept, and they think that mobility platforms will be needed in space as well. Rather than the space of space, but when we decide to go live outside in outer space, these are some of the components that are important. So the development direction of ours, and just the only difference is that what NASA is doing is going to be used in outer space. And we have a short video that we'd like to show you.
So salty, I'll still take a bite. Okay, we can take my Lambo. I'll put on a tight show. You sure you can handle? We be faster than Django. So salty, I'll still take a bite. We can take my Lambo. I'll put on a tight show. You sure you can handle? We be faster than Django. Can't stop, won't stop. I can't stop, won't stop. I can't stop, won't stop. Can't stop. Can't stop, won't stop. Can't stop, won't stop. Can't stop, won't stop. Can't stop. Can't stop.
I think it's a bit different from the robots that you normally imagine, but we are more focused towards mobility. If it's a place that a human can go, then we need to be able to go there as well. Because people can move, robots need to be mobile as well. And they can extend the experience reality of humans. And similar images are already put out by NASA. And I think this is part of the Artemis and the Moon base plan. It's very difficult to replicate the exact same idea on the Moon, but I think we have many similarities. This is the same for the energy area. We say that we're good with hydrogen, but that applies only on Earth. We don't know if there's enough oxygen or hydrogen on the Moon, so that is the issue we need to solve. However, since our specialty lies in hydrogen, I believe that our research can really contribute to that area. I'll show you a short video.
For centuries, humanity longed to journey to the moon. Unlocking the potential of hydrogen made it all possible. Electricity made from hydrogen powered the spaceship, and the astronauts drank the water produced by the fuel cells. At long last, mankind's dream to set foot on the moon was finally realized. Decades later, hydrogen fuel cell technology in our vehicles is ushering in the age of clean mobility within a sustainable hydrogen ecosystem. As mankind took its first steps on the moon, billions saw our precious blue planet from space. Humanity's giant leap to the moon revealed instead the fragility of our Earth. Our future lies in a net zero society, and Hyundai Motor Group is creating it.
This is a video that we made a few years back, and I think this really, I hope it touched the hearts of people in the space industry more than us. In hydrogen, We know that there needs to be a lot of energy in order to launch a rocket. So that's one area that we are looking into. And we believe this will be used in other areas as well. However, when we look at the timing, resources come first. Even so, we are doing a lot of advanced research so that we can continue to contribute to this field. This is based on dollars. It's probably the same material. We are thinking of 1.1 trillion. As civilization develops, there are problems that we solve through concentration of urbanization and then solving those issues. It's impossible to expand infinitely. So how we use these resources effectively, efficiently, 3D as well as AI usage will be very important in these solutions. And we also have to think about going into outer space. In July, we created this agreement. I think you may have already seen this. And we're talking about unmanned exploration on the moon with these public entities. And we are working with these institutions on this research. And we don't have any detailed results as of now, so that's what I want to touch upon. I hope that we can give you more details next year. If we look at the collaboration, the 6 companies that I showed you earlier, plus other companies and universities are joining us in the effort. And we're going to have research projects with these entities. And sorry, this is a little bit off, but we have to go for a multi-purpose mobility. And you saw in the video as well, this is the research direction that we want to go in, and we are going in on the Earth, and we want to apply this to the space whenever that is possible. So we want to take the concepts that already exist to expand it into outer space and onto the moon. So that multi-purpose platform is what we're trying to go towards. And as I mentioned earlier, I think mobility is probably only going to be used on the moon so far as we know, other than the Earth. And I believe the challenges lie there. And since that is the only place, it means that we have to recreate everything anew. And we have to be able to manage that, which is a challenge that we need to overcome. It's difficult for us to do it ourselves. And I showed you this collaboration structure. And even if we do have that collaboration, at first it's always hard. So it will be a little bit more of a conservative approach that we need to take versus the one that I just showed you. And we also have infinite possibilities in terms of expansion. So we really want to be successful. Lastly, we have this mobility vision in this 1-minute video. Although we are not on the moon or in outer space yet, when I am asked, why is Hyundai interested in space, I want to say this is an extension of our mobility vision. Hyundai on Earth, Hyundai on Moon, and Hyundai on Mars are not that different. And when we are able to reach these goals, I believe it will be useful in the competition to the moon or to Mars.
Have you ever wondered if there's a limit to our imagination? As humans, we've always been on the move. With robotics technology, we open a new era of human advancement, where mobility defies imagination, where technology helps us overcome limitations, where the virtual and physical merge into one in the new era of meta-mobility. With robotics, we strive to expand human reach. We never limit what we challenge. We challenge our limits. Expanding human reach.
So that was my presentation. Thank you for listening.
예, 김세용 책임님 감사합니다.
Thank you very much.
주서 훨씬 더
You prepared a lot of videos, so we can really see what you're saying. And I think through these videos, you could really see the future vision that you are envisioning. So why is Hyundai Motors an automobile focusing on space is a question that you focused on initially in the beginning of your presentation. I think that vision of Hyundai came from a vision towards the future, how to realize the era of mobility, we have to venture out into space. So listening to your presentation, I really was persuaded, and I could see why Hyundai Motors decided to embark on this journey. So I have a question for you as well. In Korea, for a long time, there's been expectations on big companies venturing out into the space industry. Hyundai, a long time ago, actually made the first inroad into space. But then after that, for a long time, Hanwha was the only big company that invested in space. But now it seems like Hyundai is expanding into space once again. Hyundai Motors has currently taken on the acquisition of Boston Motors and also is participating in Artemis project. I feel like as Hyundai Motors, as a big company like Hyundai Motors takes on such space products, you must have competition, right? I'm sure you do market research before you enter the market. So my question is, who is your competitor, or what is your competitiveness? What is your competitive edge in the future mobility sector? And what are some of the risks that Hyundai Motors faces? The question is quite broad, I feel like. Right. Well, I think we should first focus on the question, are we in a field where there is a competitor in the first place? We say that we are going to go to the Mars soon, but because it is a distant goal, we will first of all maybe venture out into the moon, right? And people will start living on the moon, and mobility will be a key area for people to reside on moon. We're actually not investing in this mobility area thinking that it's profitable, and I think that Toyota and GM, so other automobile companies, would agree. That's why I say that we are not at an age where we think of competing with other companies. I mentioned hydrogen fuel cells. Hyundai Motors is not saying that we're going to dominate or monopolize the hydrogen fuel cell market. We're at a nascent stage altogether, all of these companies that are investing in this new market. So to turn to economical aspects, of course, along the way, I mentioned a few times, but let me repeat myself. We don't think that this market is profitable at all. There's no market, actually. the robotics market in total may be able to grow to a significant size because that technology would be needed for the thousands of satellites there are. If these satellites need to be serviced, then of course robotics arms would be very useful. But when we think of mobility for the moon specifically, for people, we are not sure if this is a profitable sector. So we are exploring our options right now. Companies like GM and Toyota made similar declarations to Hyundai. And through this mobility platform, our plan is to expand the services we provide to people and assist moon or lunar exploration. So we're focusing on mobility platform. That also is in line with the mobility sector that we're focusing on Earth. Thank you very much for your answer. I feel like Korea has truly become an advanced country now that you say that a private company is not focusing on profits and expanding into a new market. So we have a last speaker waiting to give his speech. After we hear from the last speaker, we will have a Q&A session where we take questions from the floors. That's just a reminder for all of you. Last but not least, we have a maritime company CEO who will give us his presentation. I'm talking about Aerospace Satellite Solutions, Song Min-jun. Please give him a big round of applause. Hello everyone, I am Song Min-jun from Aerospace. We were usually focused on maritime control, so we provided services to the government services. And also, when there were military activities, like trajectors that would fall in the sea, we would dispatch our ships prior to where they would fall to collect them. And now we have expanded further to the space sector. We have been merged with another company, so after we merged, we have now expanded into the space sector and we are past the incubating stage. When you look at the first slide, you can see what I am going to be presenting on. We have a maritime launch pad and a ship to collect, retrieve the parts. In the investing pitching session, we had startups like KMAX give their pitches. I wanted to ask a question to them. When you launch rockets, where are you going to launch these markets to begin with? I wonder if they're thinking of these questions. Domestically, as we're planning for rocket launches, we couldn't find a suitable environment in Korea. That's why we went to Brazil. And right now in Korea, a private launch pad is being built, but to complete that construction, we will need a lot of more time. Next year, I heard that Unastella is going to launch their rocket. So I was wondering, where are you going to launch your rocket? If you give me your name card after this presentation, we'd be more than happy to collaborate. So I'm going to talk about 4 aspects. So first of all, I will talk about trends in the space industry using domestic and foreign seas. Second, environment status of marine launch and collection in Korea, introducing a marine space support platform suitable for the domestic environment, and also future possibilities of maritime space support platforms. First, let me briefly introduce our company. Right now, we have various business lines regarding marine launches, and we are planning to provide various launch solutions. Our biggest area is marine launch platform sector. It means controlling and monitoring areas where these rockets would land at in sea, trajectories would land at sea. Now, from this month, we are collaborating with a university to develop satellite-related parts. Also, when it comes to ground support equipment, we are carrying out various projects. We are creating a large space simulation chamber. And our plan is to start on that project from the end of 2023. I think this is something that you are used to. Now we are focusing on reducing costs and increasing the payload on the rocket. In the age of new space, the goal is to cut costs. So that was a question we focused on. How can we do that in Korea and make this a profitable business? Let's first look at the overseas trends. To be a fast follower, we have to, of course, look at the pioneer. I'm talking about SpaceX. SpaceX is retrieving the fairing. They have tested retrieving and collecting the fairing, and they recollect the parts and use that again on ground. Before, ships would travel 70 kilometers per hour and retrieve the fairing in sea. However, once a ship makes a curve at that kind of a high speed, there's risks of the ship going overboard. And also, we believe that because of various needs and demands, it would be good to create a launch pad on the sea in the beginning. So Falcon 9 added a GPS system and tried to retrieve the fairing, but it was difficult to do so mid-air, so they gave up on recollecting the fairing in mid-air. Now they succeeded in recollecting fairing that fell 1,500 kilometers far. Usually that distance is around 500 kilometers, and for fairing it's about 1,000 kilometers. Then why do we recollect the fairings? They seem like just shells. We can just throw them out and make them again, right? Why do we need to recollect them? Let's say that making a rocket takes about $42 billion. About $6 billion of that is used to create the fairing. And also, last year, out of the 48 satellites that didn't use fairing, a lot of them used recycled nose cones. So basically, various parts and materials of satellites are reused already. In terms of recollecting fairing, it's difficult because it could virtually land anywhere. That's why we have to widen our range of control. Let's look at China. They have two versions that they use to test the launches, the marine launches. They used a cargo barge and also a PSV ship. Unfortunately, these were not stable launch pads, and they used a cold run launch method, which means that when the ship shakes or when the launch pad on the ship is not stable, it's not as crucial. For Israel, they took on a different approach. As for missiles, just like Korea, they don't have a lot of territory. Usually it's most ideal when one side of the territory is surrounded by the sea. They used a bulk ship and they loaded a launch vehicle on a bulk ship. In terms of Russia, Russia was the first to do a marine launch. They had a launch ship and a ship to control the launch. A lot of it was successful, but it was very expensive to operate the ship. So it seemed like the ship wasn't fit for small launchers to be boarded, and it wasn't deemed as profitable.
There are 3 cases in Korea. It's not marine launch, but it is from land launch. Private small-size rockets were tested on the west coast of Jeju. Also, this is one that we participated in, is the marine launch of Korean solid fuel rockets. We have barges, and we detached and we were able to create a launch condition similar to land. Because Korean barges have limitations, we had to do it in a very small space. We do need to introduce different types of launch pads. And then we have hybrid launches, and that will happen next month in Brazil. And I'm going to Brazil next Wednesday as well for this. There were many issues, as mentioned. And we wanted to launch Innospace in Korea, but we weren't able to. And we hope that we can do that in Kohung in the future. Also, we want to create bigger rockets, and in order to do that, we need to have bigger launch pads and be able to retrieve them in the future. Once we are able to provide that support, and we put that rocket in the launch pad, those are some of the things that we discussed. And I think that will take about 3 to 4 years in the future. On the west side of Jeju, it seems very ideal to be able to launch a private satellite rocket. As the policies and support is changing, once they say you can't do it here, it's not the end of the story. We can go around and still ask for approval, etc. And I believe that the country can help us in various areas. And since our president is very interested in this area, I think we can receive a lot of support. There's Kohung and Jeju as very ideal sites. I'm not sure if you can see the picture very well, but the safety region in Kohung can be done in a 10-degree manner. And Jeju is 30 degrees. And if you see in the green, that is the range that retrieval is possible. In the yellow, pairings can be retrieved. And since we are a marine company, and as you can see in the red areas, this is where people are, so it is very important that we don't have things fall in this area. And I think there are many things we need to consider. So why do we need to retrieve them? And this is the same for Aerospace. If we throw everything away, we can go 100% non-reusable. So if you think about it, we have to launch it, and if it's a reusable, then we have to bring it back. And these rockets fall straight down, so it's 70%. So even if you just look at the math, it's a much better deal. And if we look at the least costs, even if we take that away, that would cost us 240 billion. This is from the Jeju Space Forum, where we talked about which area in Jeju would be ideal. Said Jungmun was one of the areas, and that could create a lot of synergy with tourism industry as well. However, the waters aren't deep enough. So we looked at 3 areas in Jeju. And on my vacation to Jeju with my family this summer, I took these pictures myself. And we wanted to create a launch pad here. However, due to activists, we were not able to proceed with this project. So I think all of these candidates are great. This is the area that I would recommend the most. The waters are about 40 meters deep, which is quite shallow. So the barge or the launch pad would be ideal if we put it here. We have about 40 degrees. And on the yellow, you can see there's an area. That means the vessels, the area that the vessels can reside is very small. And I think this is the area that we can control very well in Korea. Okay, so we don't have a lot of time, so let me try to rush through this. Then how are we going to launch with what equipment? The first is the jack-up rig. That would be the most basic. You need very shallow waters, and that could be small to mid-sized. And the payload needs to be less than 1 ton. The semi-rig is in the middle. And I think the drill ship is the type that Korea would prefer the most. Of course, it would be best to do it in deep waters, and you can have a higher payload, so this is the very ideal type. When we launch on the jack-up rig, this is the process you can see on the left. We create this facility, and then once the rocket is assembled here, we bring it onto the sea, then we jack it up, and then we launch it from the sea. The first vessel that we will bring in is a barge. It'll be 100 by 350. And the payload can be up to 1 ton for this barge. So let's skip over this page. The most important thing here in the new space era, I think new space and old space need to come together. And the launch pad and the retrieval process need to come together. It costs 5 billion for the first stage, but then when we go on, it can cost 3 to 4 more times. So I think if we are able to use these boats for different purposes, I think it will be profitable. Therefore, I think we need to prepare this phase by phase. So when Korean companies are ready to launch, they are able to find a company that can share the launch pads. I think Aerospace is creating a small launch pad, but I think you need to focus on your key capabilities and partner with other companies that can provide the services that you need. And I believe that will allow us to grow faster. Let's talk about retrieval. After retrieval, and also managing the safety area are other issues. But being able to create this vessel, big enough vessels, is the most important thing. And even if we start the business tomorrow, it will still take a long time for us to get prepared and have that ready by next year. So I think if you can provide that policy support, that would create great results in the private sector through that partnership. Thank you very much. Thank you, Mr. Sung, for that presentation. We talked about marine launch. And I think this is something that has become familiar to us, but just a few years ago, it wasn't even a buzzword. However, now that we know that launch pads will be in demand more and more, it has become an area that a lot of people are interested in. I think from last year onwards, this has been a buzzword. And when I met you last year, I was very interested to hear that it seems like it's a buzzword now, but you already had studied a lot and found out where the launch pads can be situated in the Jeju area. So thank you so much for explaining that in your presentation today. I want to ask you one thing as well. You covered a lot already. However, it's only been 2 or 3 years since this situation has risen. And I think you have a lot of work done in other areas as well. And creating this in the business sector is a whole nother story. Was there a reason you started this, or how did you start this? And I believe that you saw many business opportunities in this area. And I believe you have contacted Parrish, and it feels like you have an ulterior motive, but can you answer in relation to all of these factors? When you thought this could be a market, and when you saw this opportunity? First of all, we decided in 2022, March 31st. We controlled a huge strip of land of 100 kilometers, which is a huge piece of land. And we were controlling it, and then we looked, and we really wanted to go in there. And we wanted to go in there and get in the space industry, but we didn't know what to do. So that's when we started the business. So I read a lot of books, 20 books on space industry. And I also have a mentor. So I asked and got feedback on whether this is the right direction and tried to figure out if this was the way we want to go. And we created the corporation on August 30th. So it's only been 4 months, and in that short span of time, we made that ground station and the satellites, supporters, etc. And I want to tell you, if you work really hard, it works. We're the first company to have that IP26, and we provided that during President Park's administration as surveillance drones. So it's very difficult to get started. And when I got into the industry, I found that it was very difficult. So I am going to continue to work with professors and other institutions. And if we help each other out, I believe we will have good results. So I also want to tell you, rocket companies, don't worry about this because we will provide it for you.
As we hear all of these speakers, it seems like it's very important to find opportunities before they become widely known and to research on them and form partnerships to expand areas of cooperation. So that's it with me and my questions. In the remainder of the time, we will take questions from the floor. If you don't have any questions, I'll be happy to ask more questions because I have a lot of questions on my mind. If you raise your hand, we will pass the mic to you. I see a hand. Hello, I am Park Jong-ho. First of all, I'd like to ask a question to Mr. Song. So reusable launch vehicles is a distant dream. I think it's difficult to actually predict when we will be able to see the actual results. I'm sure that you need a lot of investment. You have a lot of expenses for R&D, right? And to make up for all of those expenses, it seems like you would need some demand in the domestic market. I want to ask a question about that. I think your question overlapped with the previous question I got, but yeah, so sustainable business model is very important. So we do marine construction as well, and we also support windmill construction, buoys. So we do see some room for profitability. I do think that it's not possible to reap enough profit with this retrievable business alone. So we have other business lines, and we're going to utilize those business lines. Also, we feel like there will come a time when more launch vehicles are launched into outer space, maybe in 2025 to 2026. We feel like it'd be enough if we use our vessels to retrieve the launch vehicle's parts. So I'm not that worried. Does anybody else have questions? Yes, I also have a question. This is a topic that everybody is focused on. So marine launch, many people would think of it as just launching a vehicle from the sea, but to rephrase it, it's launching the naru in the sea, on the sea. So you need to know all the details about the center, what is needed to launch it from a movable launch pad. You focused more on vessels today in your presentation. I think you missed out the details on the space center part. So I wonder what kind of a structure or a system you have in mind for that. So you mentioned an idea on movable Naro Center. That would mean safe data centers and other research centers. So that will need an additional vessel that will not be created on the same vessel. I think that's out of our scope, actually. For liquid launch vehicle engines, it might not fit our business model because they need a lot of parts and materials, and also they could explode. So we don't think it's fit for launching marine launch. We do think that a hybrid model and a solid model can be covered by our ships. But when it comes to liquid engines, we will need to research more on that to make that feasible. And also, because we are in our initial stages, we don't have a lot of information on the additional aspects that you mentioned. That is a shortcoming of us, and I think that further communication will be key to keep on developing this all the more. Okay, we'll take one more question.
Mr. Zhang? Thank you for that amazing presentation. It was very interesting. Since everybody asked Mr. Song, I want to ask Hyundai Motors and Poryong, Mr. Kim and Mr. Lee. Private-led space industry means that space technology is technology for the Earth. And I believe both of you are investing in this sector. Is there a space technology that you want to invest in that can be helpful for humanity on Earth? You didn't mention it, but I want to know what you see in the possibilities. Hi, I'm Kim Se-hoon from Hyundai Motors. May I ask where you're from? I'm the president of Donga Science, the host for this event. Yes, so if I understand your question correctly, you're asking about space technology that can be helpful and applied on Earth. Is that correct? For our case, we have technology that has been created on Earth based on Hyundai's robotics or mobility technology. And we want to converge that with other space industries to go to the moon. So anything with legs or wheels is what we think of as mobility. And I think maybe in the future we can fly, but in order to do that, we need the air. For now, our mobility is focused on moving on the ground. Thankfully, we already have a business foundation on Earth, and we want to expand that. And we talked about expanding human reach, so we want to expand the human experience through our mobility technology. And we want to converge that with space technology to go even further so that we can reach further areas. I don't think that technology is reserved for space, and I think that's the difference between our technology and rockets. For us, technology and business on Earth is still very more important, and we want to build upon that. So rather than technology for space, I want to say we're in the process. Hi, I'm Ijuni from Boryong. I'm not sure if this answers your question, but since we have not started the business per se, we don't know the results yet. When we talk about healthcare in space, we have to think about the environment and health in space. However, it's not only limited to that. We think space itself has very much possibilities that are new. And we also have to think about the opportunities that the new environment can bring to us on Earth. So if we listen to many space companies, they say it is a mutual exchange. Therefore, we need to be able to use these technologies, and bio companies are also looking into that. Thank you very much for that answer. Our session was 1 hour and 30 minutes, which was longer than the other sessions, but I believe it was quite a meaningful one. And expanding the externality of space would be very important in the space industry. I believe your business and projects can really contribute to expanding the space industry ecosystem. Thank you so much for joining and listening. Thank you very much.
큰 박수 부탁.
Please give them a big round of applause. Thank you very much for that insightful session. May I have your attention, please? This has been a long session and a long forum. I feel like you all must be a bit tired. I'm not sure if this is a good news or a bad news. If it's okay with you, let us cut the break short and skip over the last break to listen to the last two presentations. I think that'd be better. I think a break at this time would just tire you out even more. So let's go to the next session. Now, the first session will be on the talk of workforce development programs of Korea. It will be given by the head of the Carey Academy Center, Moon In-sang. Please give him a big round of applause. Hi, as introduced, I am Moon In-sang from Aerospace Education Center of Carey Academy. Today, I want to talk about how we can expand the talent pool and what activities we are engaging in to expand the talent pool. The order of my presentation will be as follows. First, I'm sure that not many of you will know of KADI, so I will explain how KADI Academy was established and how it is formed, so the structure of it and the programs in KADI Academy. And of course, last but not least, I will give you an overview of national programs home and abroad, what kind of companies are engaging and what kind of activities to engage there to expand their talent pool. Now, before I begin, I want to talk about Star Trek. It's a sci-fi movie that I loved when I was young, so I always talk about the line from Star Trek, an sci-fi drama. There's a line, the final frontier. These are the voyages of the Starship Enterprise. It's a 5-year mission to explore strange new worlds, to seek out new life and new civilizations, to boldly go where no man has gone before. I was very touched by the first and last lines. The final frontier. I feel like we'd all agree on that phrase. Earth is a mere small part of outer space. When we look up, we see the sky. It seems very close, but we can never touch it, right? And the last line, to boldly go where no man has gone before. I feel like you all are trying to go where no man has gone before. So I want to say that you're all pioneers, adventurers, explorers. Now, what do we need to do to go to a place where no man has gone before? Of course, we need to develop technology. It's not easy to go to space. We need advanced technology, and we need multiple technologies. We need technology application. All in all, efforts are needed. We need a lot of people, a lot of talent on board. Also, we can't let all of this technology that we developed die. We have to scale up the technology. We have to pass it on to the next generation. We have to teach the next generation about this technology so that the next generation can explore outer space in a more advanced manner than us, and so that we can contribute to society. That's why I believe that education, training is very important. So let me first begin by telling you how KARI Academy was established. KARI Academy is a newly established academy, actually. We were founded on the 16th of July 2021. We started off small, and we used the library within KARI and the Space Center in Daejeon. We invited about 70 lecturers. So let's look at the legal basis of KARI Academy. We have our basis on the Space Development Promotion Act. The reason why I mentioned the Promotion Act is because KARI is a government-related institution. We always have to keep to the laws and regulations to create academies like this. I just wanted to stress that we abided by all regulations. Also, because we have this KARI Academy, I want to say that businesses, startups here can make requests comfortably to KARI. There's Article 5, Formation of Basic Plan for Promotion for Space Development. It says that every 5 years, long-term and mid-term policy objectives and basic direction setting on space development should be proceeded. Also, the basic plan shall include the following. The first is matters concerning the nurturing of professionals necessary for space development. And Article 7 is on designating of institutions specializing in space development. Of course, that institution is KARI. So we are abiding by this legislation in establishing the KARI Academy. Also, according to the fourth basic plan for space development promotion, there's 4 pillars. And the 5th pillar is on education. We need to nurture talent pool and increase development on space internationally and raise public awareness on space. So these are the basic plan pillars that we need to focus on. I'm sorry, these are 5 pillars actually. So we need to create a foundation for education and nurture students and professionals regarding space sector. Also, I want to mention the regulation of Korea Aerospace Research Institute. It means that it says that the institute will perform the following to achieve the objective described in Article 1. We must support the establishment of Korea Aerospace Development Policy and transferring and spreading aerospace technology and information, and cultivate human resources in various aspects. So once again, we follow through on these regulations. So what is the basic structure of KARI Academy? First, there is the Education Committee. Next, we have a depository, a library where we have all of our research results stored, and also the Space Science Center in Goheung. And we have an education committee and 70 lecturers to give lectures about the developed curriculums. We plan to expand the number of lecturers going forward. What are some of the programs that we have right now in Kari Academy? We have government-led programs and also private-led programs. First, let's go into the public sector-led programs. This is an ongoing project from last year. We have training provided for students in the field of aerospace. The first course is a 3-credit regular graduate school program. And through this program, students can learn to assemble and test satellites. And for undergrad students, we have the second course, which lets students make antennas and get signals on those antennas and analyze the signals they got and create a map through coding. So we have this in-the-field training program ongoing for 2 years. And this might be a sensitive topic, but one of the missions that we got is something that I feel like everybody will agree with. We don't have a lot of females in the industry. So the Ministry of Science and ICT said that we should motivate more girls and women to participate in STEM-related area activities. We are cooperating with USA, which is an organization under United Nations, to promote more women talent in space. Also, Israel students, female students, came to Korea for a partnership of this program last year. And this is also a new program that we have. Right now, we're talking about the fourth industrial revolution, new space, and companies need a lot of manpower. I've also heard a lot about that on the ground. But when we go to universities, we see that graduating students complain about not having enough companies to go to, even if they majored in aerospace. I mean, what kind of a discrepancy is this? Companies have difficulties finding talent pools, and students have difficulties going to companies. That's why we created this industry academia collaborative project to connect graduating students with companies better. So we are currently designing policies to propose to the government, in particular the Ministry of Science and Technology. And we also have this CubeSat ongoing contest. 4 CubeSats were launched to the sky, right? One from Chosun University, Yonsei University, Kaishi University, and the last one I can't remember where it was from. And these successfully transmitted data. Some of these CubeSat successfully transmitted data. So this satellite is well received. That's why we are thinking of expanding more educational programs related with CubeSat going forward. Every 3 years, we hold a CubeSat contest. We can't give every university an opportunity. Unfortunately, we go through a selection process. With universities, and universities that don't make it to the final round oftentimes feel very sad because these students in universities pour their heart and souls into making a CubeSat, which takes a few years. And then these students graduate, never having the chance to participate in this CubeSat contest again. That's why we decided to expand the CubeSat contest opportunities more going forward. Next, we also have space camps for young children, elementary, middle, and high school children. And we have CanSat, which is teaching how to build these models. We provide this to schools in remote areas, and we have an ongoing mentoring service. And in September, we brought a lot of students to IAC to create an international networking opportunity. Also, within Cuddy, there's a mandatory education. We also organize that. And we also provide education for individual Cuddy members. Also, we provide education, space education to private entities upon order. We try to form the curriculums that private businesses want when they make requests to us to train their employees. So basically, if a company tells us that we need education or training in this and that sector, we try to recruit lecturers that are fit for that curriculum. I see that a lot of startups are here. If you need a certain education curriculum, please just make that request to us. We will try to give you a tailored education curriculum and education program. Now let's look at the overview of national programs. Of course, other nations have national space promotion plans and carry out their education programs based on that promotion plan. So there's the Ministry of Science and ICT, and under the Ministry of Science and ICT, there's CARI, KASP, SATREC, YAC, KTL, KIRD, KASP. Is an organization that was founded on May 2014 and has contributed greatly to producing great training programs. A lot of people that took the training program are now in the space industry. Every year, 50 to 100 people are educated. And right now, I heard that they're going to expand the program. Next, we have SATREC, which is part of KAIST Research Center. It doesn't focus on educating many students. It focuses on a limited number of people to educate. Every year, about 10 people are admitted to this system, and they go through an intensive satellite-related education education program. And then we have YAC, which was founded on August 1989. It provides education for children, so lay people. It has mentoring programs, school teacher training programs, international networking programs. Thank you very much. This wraps up my presentation.
Thank you, Mr. Moon, for that presentation. Are there any questions for Mr. Moon? All right, can we have the microphone?
I heard about the education program. It's the first time that I've seen a presentation on this. Do you have your roles set out between universities and KARI Academy? Yes, we do. In universities, basic skills are taught and basic disciplines are taught. So we have on the site in-field training. Actually, we use a lot of laboratories that are located within KARI, so we can train talent. Okay, so let's say we had a national agency right before, and KARI actually is a spin-off from that agency. I'm not talking about that right now. Already, I know that there's a program in that national agency where teachers are educated on space and they receive certificates after they get training. It's great that the government is investing in these education programs. My question is this: the KARI was established for research, right? Why are you educating students? Are universities okay with that? Yeah, we're not competing at all with universities. We are cooperating with universities. We have never really had a feud or a conflict with universities. Yes, going forward, I hope that KARI Academy will continue to provide training fit for the sector. Thank you very much.
Now we have the last session of our forum. The next session will be done around Future Space Education Center. The head of Education Center at Busan University Future Space Education Center, Choi Jong-yeol, will be giving his presentation. Please welcome him with a round of applause. Thank you very much. Hi, I'm Choi Jong-yeol from Busan University. Thank you so much for staying till the very last session. I'm very grateful for you staying till my presentation. I'm going to be talking about the Future Space Training Center that is in relation to the Ministry of Science and ICT. We're going to be talking about the overview as well as the plans for the Space Transportation Technology Research Centers. We'll talk about the overview of the Future Space Training Center. Before we go in, I want to talk about something that's not on the screen. Korea's space development starts with talent development. 우리별 1 was the first of our space development, which was a satellite. It started as a ERC, a research center. Professor Choi Soon-dal, who sadly is no longer with us, created this research center for this artificial satellites. And from there, we got 우리별 and 우리별 2. And the talent from that pool have become experts. and it created the venture company Sarugai. Another example was in early 2000s. The Ministry of Science and ICT led projects. However, it was very difficult to do in the space arena. We had the NSL project, and it has been selected as a basic science and technology area. Hybrid rocket research project was selected, and the talent from that pool is part of Innospace. In fact, they're the founder, and Mr. Kim Soo-jung is one of those people who will be launching in Brazil next month. So as you can see, talent development has very important history and heritage in the space arena. So the MSIT has plans to create this training education center. This looks at the goal. We needed strategic talent development, and we needed consortium base between the academia, companies, and institutions. There are 3 areas: space transportation technology, space exploration, and space resource utilization, and finally, space communication technology. And there are 2 other free submission areas. So a total of 5 areas. And this will take a consortium format. The MSIT will select centers to support, and each institution will take 30 talents that they will support. So these are 5 centers that have been selected. Busan University has rockets and transportation in their training center, and resource usage and exploration has been selected as part of Inha University. And Mr. Choi Ji-hwan of the Korea Science and Technology Center will lead the multi-mission low orbit. And Gyeongsang University and Sejong University have also been selected. I want to talk about each of the centers. Let me talk about my center first. One of the new technologies that I want to talk about is, as you can see on the presentation, this is just a diagram, and students can make this. They will go through a very systematic process similar to ones that research centers will go through, and they will design it, and they will use that technology to actually launch the project. And these schools will take care of the basics. Innospace and Korean Air are companies that are really supporting this effort. There are other research institutions and centers that are part of this effort as well. And when we look at the roles of each of these entities, we have engine technology, This is pressurized engine building, and we will launch that through the help of InnoSpace. And the telecommunication will be done by Korean Air. And as you can see, it goes through the entire process or life cycle. Inha University is in charge of space exploration and resource utilization, as you can see on the presentation slide. First of all, we look at accurate flying and journey. I say there's water on the moon. Being able to use this water will be important. And propellant technology and technology to identify this water, as well as rovers to identify, are all very important technologies. So we are helping students select and develop through a scenario analysis of these resources. There are many different institutions that are taking part in this effort. Of course, there are universities, companies, as well as research institutions. And that is the Inha University process. I'll talk about KAIST now. Satellite constellations is their area of expertise where they will be developing talent in. And as you can see, many entities are also part of this project. Institutions and research centers alike are going to support the students in this talent development program. KARI or KT are very close to this. Key technology for small size satellite in the constellation for low orbit is the main topic. There will also be development of propellant technology that has high trust and very low costs in the low orbit. That is the key research topic. KT, Hanwha, and KARI are all collaborating for this topic. Science institutions and municipalities in Korea have come together to put the center together. At Sejong University, they looked at Future Space Navigation and Satellite Technology Research Center. This is for not just the low orbit, but also going to the moon. And in that case, how are we going to run the system? What will the infrastructure look like? Those are some of the questions that Professor Park Byung-un is going to be answering with his team. And many institutions are also taking part in this project as well. I wish I could tell you more in detail, but that was a very quick overview of what each of the centers are doing. And I'm going to talk in detail more about our research center. We said the preliminary rounds have been done for certain topics, and talent development was not one of them. I believe that basic research is still an area we need help in. Therefore, we have this RFP. It's not easy. We can't just have the people. We have to be able to do creative space transportation basic research. And we also have to nurture comprehensive experts in this area. And being able to have those talents grow and creating the model and evaluating them is another thing that we have to do. Our goal would be to create new and attention-garnering, innovative, potential transportation technology in space. They need practical and participation in the labs in order for this curriculum to be successful. As a very innovative technology, we have taken leadership in this role, using liquid fuel and making it available for small rockets. Two-stage rockets is our goal. That was the slide from before. These are two companies that are participating, but there are also 6 more, as you can see, and 4 institutions, and the 2 CASP and Busan City are all participating. So that's the structure. Let me move on. Our key area is to look at new rockets with new technology and launching them. And the Ministry of Commerce has said that we need to focus on parts, materials, and equipment. We do research in detonation engines. And Innospace is a launching company which we are collaborating with to pull the project to a close. Also, let's talk about retrievables. Parachutes are the best way to retrieve recyclable parts. And we want to have that technology ready as well. Many companies are participating. We will go through this process. Up till now, when schools did such researches, we mostly focused on writing papers. We didn't focus or participate in developing. So having this opportunity to take each of our roles and contributing through this collaboration is a great opportunity. I think it's a good opportunity for students to take part and see for themselves how technology is developed. So the professors and the institutions taking part in this are listed up here. And so students are able to have exposure to very systematic research processes. And this means bringing in experts who have that experience. Although other opportunities existed, we were not able to have them do that in the rocket field. And so having this opportunity to do that all the way through the rocket launch phase is a great opportunity. Let's talk about the ripple effects. Some people say it's a small rocket, where are you going to use it? But if we actually scale this up, it can be used as small-sized rockets. I'm not sure if you can see the small picture. But there are companies that are preparing for actual launch. And since a lot of people are interested in this field, hybrid rockets have been attempted at as well. And we heard our country is interested in launching with the KF. And if we are able to develop our rockets properly, I think they will have usage, as I have mentioned just now. There aren't many places in Korea where the 747 can be launched. From Busan municipality's point of view, the Kadokdo new airport is another thing that they want to do. Kimhae Airport is actually a military airport. And I believe that if we create the new airports, military and other commercial usage, also people can use it for commercial usage. And the military Air Force transportation port is right there as well. The surveillance aircrafts are all operated out of this area. So we have demand and supply and the operator here. And I believe this is a candidate for space airport for Korea. Busan was famous for ports and logistics in the past. I think in the future we can take over the space industry as well. Busan has not been active in the aerospace area, but I believe it holds a lot of potential through this project. We have many R&D institutions and companies that are part of this effort. And many stakeholders would compete, but there hasn't been a chance for them to come together and collaborate. We are universities, and I believe we are a step away from that. We have to think about science and research. So I hope that our research centers are operated very well and like-minded people come together for the development and research of space industry. Lastly, I would like to that was the presentation on our research center. Thank you for listening. Thank you very much. Mr. Choi, thank you for that presentation. Are there any questions to Professor Choi? Okay, let's have a comment here. It really seems like a great effort. I have one question. I think the infrastructure will work out for the best. Does the talent developed here have places to go? Did you do research on the demand and supply of talent? Where will they go be employed? No, I did not do that myself. We are in the SRL and the SDL phase right now, and the InnoSpace and Korean Air are some of the companies that we are working with, and they are very happy with the results so far. And students are able to work with these companies directly and learn from them. So they were able to have hands-on real-world experience. And from the company's point of view, it was great for them to see that students have this capability. So they were able to employ these students right away. So it's very early stages for us now. However, as students have experience in the real world, that will help them in the future. Also, at the end of the day, there aren't a lot of space companies in Korea. So if these people are able to go into these companies, I think they can even take leadership roles or they can create their own startup. like Cetrec, I, and InnoSpace are some of the very good examples.
센터장님께
Please give him a big round of applause. I hope you enjoyed all the previous forums. We have now come to the end of the two-day forum held in JW Marriott Hotel Grand Ballroom under the topic of Korea's vision for space economy. We kicked off the first day with the Future Space Economy Roadmap proclamation ceremony by the President. And we touched upon various topics with 28 speakers from home and abroad with the topic, the world space economy and the challenges of Korea and corporate challenges. It seems like the keywords we're left with is next generation talent, nurturing, and sustainability and earth. Those three words stuck to my mind the most because they imply the direction that we should go into. On the first day, we discussed the roadmap. And I feel like Mr. President shed a light on the direction we should head into. And I feel like public and private entities will be able to connect the dots that the President has set forth for us. So this wraps up the fourth Korea Space Forum. I am all the more happy to see the Korea Space Forum grow more year by year. Always remember that I also am enthusiastic about this forum. Now let us wrap up today's event. I thank all of the organizers as well as the co-hosts for contributing to this event and for showing great support. I am Yuna, and it was a pleasure being the MC for this event. Thank you.